Okay, so welcome everyone. My name is Stéphane Lebel. For those who don't know me, I'm Executive Director with Fenestration Canada. Welcome to this first ever CGC, or Canadian Glazing Conference. We're really happy to see you guys here. There's a lot of people. Everyone looks excited, so that's great. We expect a lot of people today, so those who have a chair right now, I would tell you to find a way to keep it because I think it's going to be a resource today. But yeah, so welcome again. Welcome to CGC, the first ever edition. Bienvenue à tous à la conférence canadienne sur la vitrerie, la première édition. Donc, merci d'être présent. I would just want to let you know that there's been a little change to the schedule. Starting at 4, I think, this afternoon, we have a cocktail hour that's going to be added. So make sure you stick around for that. That's thanks to our friends at Sherwin-Williams. So I'll invite you to go see them and thank them. They're this way in the room. So it's all thanks to them. I guess that they felt that this was needed after a full day of education and networking. So without further ado, I'll give the mic to Terry Adamson, our technical director that you all know.
Morning, everybody. Yeah, wow, full house, man, and not everybody's here yet, so it's gonna be a busy day. Lots of people, which is great. We're a little bit surprised when we first started this a couple of months ago. We thought 70, 80, maybe 100. I think we've got about 180 regged. So as Steph said, hang on to your seat. You're gonna need it. So first off, again, Steph said, I'm Terry Adamson. For those of you that don't know me, I'm the technical director with Fenestration Canada. So I want to start by thanking our sponsors. Without our sponsors, we would not be here today. So Sherwin-Williams, JSA Machinery, Pref ERP, Tremco, CAD-PLAN, ScreenCo, INT Machinery, Glass Canada, and Servitech. So thanks to them. We really appreciate their support. Yeah, absolutely. You bet. Yeah. So thanks to the exhibitors too. Again, you know, it's all about our suppliers that support us. So please take some time today to visit our exhibitors. They would appreciate it. So would we. All of today's sessions are AIBC approved for learning credits. Isabel will be here in a bit. She's just on a plane coming in right now. She'll have forms for you that you can fill out for credits. So thanks to, I want to make sure I get all my thanks in. Lane out at our reg desk. Lane's our operations manager, doing a great job. Isabel's going to be here shortly. Rulon, where's Rulon? Put your hand up. Rich, somewhere in the back. Geoff Makamoto right there. So thanks to all those guys. Appreciate all of their support. Excuse me. Restrooms right outside. Turn right to the elevators and then left and then right. They're just past the elevators if you need those. And I want to do one public service announcement. If your dog gets into an argument with a friend's dog, do not, and I cannot stress this enough, put your hand in between them. I picked up 9 stitches on Saturday morning, so that hand's not working too good. So it's left-hand handshakes for me today for everybody. All right, so we are going to open up this morning with a bit of an update on our commercial chapter, as well as our recruitment, glass and glazing recruitment group. So if I can get Brent to come up, Brent Friesen, he's going to do a bit of an update for us on the commercial chapter. Give me a sec to bring it up.
You want me to go here?
Yep, that's perfect.
Perfect. Hi, everybody. So it's been a really fun project to be the chairperson for the commercial chapter. It's, we started about a year ago, and in prep for here, we were just talking about some of the things that we did and some of the people we met. I think for me, there was, realize that especially, well, locally and then also, across Canada, there didn't seem to be a place for glazers to come together and discuss issues and solve problems and get education. And we felt like there's a lot of things changing and happening. And so I felt like there was a need, and these guys kind of got me on board, and we've been having monthly meetings. For example, one of the things was bird-friendly glass was an area that I was experienced with. I heard about it, what's happening, didn't know much. And so we said, hey, well, let's set up education for this. And so we got, okay. So with the bird-friendly, there we go. With the bird-friendly glass, we we put together a session together and had a couple presenters talking about the different ways of measuring and products that are out there. We put a pamphlet together and now it's on our website. So, just helping to raise up the industry and get people really knowledgeable of what issues are happening and how to navigate challenges. So that's been really fun. I want to say that it's been a real pleasure to work with the FenCan guys. I'm not on staff. I just help out with the meetings. But working with Terry, he's been fantastic, and Rich and Geoff and Stefan running FenCan, just really supporting, the industry as a whole. And we're here, we want to make commercial glazing great. So there we go. Other things, those are some highlights. We did sessions on some of the like thermal performance. Do you have a presentation? I can keep talking anyway. So, different, so the purpose of our meetings, that's okay. So for the purpose of our meetings, I mean, we're meeting monthly online, and sometimes it's an education session where we'll invite like industry expert to come out. Sometimes it's just talking about, what are some challenges and, how are people addressing those, or, what issues do we want to have? So we're trying to create a forum for input into the glazing industry, especially around commercial glazing. So that's what we're doing. We invite more people to come. It's been, it's a great opportunity to get involved. If there's problems that you're having, or you're like, oh man, I wish somebody would talk about this. This is a forum, and because we're getting started, we're figuring out what works and what people really want. We're really open to people having an impact in what the commercial glazing industry is doing. So there we go. Coming up, these are some of the things we've done. We talked about bird friendly. We did presentation, stick versus unitized curtain wall. We've set up, one of the needs we identified was just a good place for recruiting. And so we've set up, we'll have a presentation from Paul, but we set up a website to post jobs and to educate people about the glazing industry as a chance to, get them going. I read a really interesting book, the guy who built Dyson vacuums, and he was saying in the UK, if you're smart, you become a doctor or a lawyer or something like that. But nobody cares about building stuff. And he says, this is a big problem. Like, we need capable, smart, interested people engaged with the building things. And so you're thinking, oh man, like that's our problem. We need to educate people about, hey, this is a great industry. There's great opportunities and really interesting problems to solve. So there we go. And then, a couple other presentations that we've done. Thanks. Coming up, we've got some events. So we're meeting monthly. We'd love to have you guys join us. There's the FenCan, some different events here. FenCan Pacific Chapter, residential in-person event at West Tech Windows in Chilliwack. Top Glass in Toronto, the FenCan Spring Conference, and Windor Trade Show in Montreal in November. So those are some events to look for. And that is pretty much my update. Is Paul next, Terry?
Paul's next. Yeah.
All right.
Oh, they gave me a mic. Woo. Good morning, everybody. My name is Paul Warltier. I'm from Competition Glass out of Kelowna, BC. And like Brent said, I stepped up to chair the recruitment chapter for Fen Canada. You got the slides up, Terry? Yep. Because I can't remember the dates, but we've not been working on this particularly long. We launched in November 2023. And we've done some work in that short period of time. What we've tried to establish and what we are looking to do is get glazers and employers together. The industry, we know, needs more talent, right? We need more glazers, fabricators, CAD people, project managers, facade engineers. We need this. We need that recruitment, right? Everyone you talk to is talking about needing more fresh blood and more involvement to make this industry great. So what we've done is we've met with members of Ontario's Ministry of Education. We've done some educational career fairs at some of the local schools. We went to the Queen Elizabeth Secondary Career Fair. We had a booth for members at the New Generation Trade Expo at the Agriplex. And so we're getting out, and we have a table in the back where we've got our Canada Needs Glazers, trade booth. And we're going to do more of that. So I'm going to do my little speech, and I've written it down, so forgive me if I'm not looking up as much as I should. Canada needs glazers. It's difficult to remember a time when glazing had enough skilled labor to fill the demand. We hear time and again that the commercial glazing industry needs to generate interest and recruit the next generation of glazers, glass fabricators, CAD designers, facade engineers, project managers, and other glass nerds. Awareness is the #1 issue. The average person doesn't know what a glazer is. Do glazers work with bathtubs, maybe pottery and ceramics, or maybe donuts, right? People don't know, especially if you're new to Canada. You know, what's a glazer doing? And even if there was a surplus of skilled labor in the country, we would still need to compete with every other trade that's out there, right? You're going up against your framers, your electricians, your plumbers. Glazing is definitely one of these underrepresented groups. So as a national association, FenCan has taken on the responsibility of building awareness for the glazing trade. Canada's Recruitment Task Group has been created to bring together members of government, educational providers, and the glazing community with a common goal of promoting and educating others about this crucial aspect of construction. You know, the glazing trade's an integral part of any building. Look at this one here. Look at all that fancy curtain wall and all those vertical you know, glass fins. It's incredible, right? And without this critical trade, this isn't going to happen. And sometimes it's overlooked and a little bit undervalued compared to other trades in the construction industry. If you're a young kid in school and you're coming out and you're going to, what am I going to do with my life? Maybe I'm not into the computers. I'm not into the, you know, the electronics. I want to do something with my hands. Glazing's not the first thing on their list typically, right? They maybe even haven't even heard of it. So this lack of recognition has led to a shortage of skilled glazers and a decline in interest among young people pursuing a trade and a career. I talked a minute ago, but we met with Ontario's Ministry of Education. We showcased glazing at the Queen Elizabeth Secondary's Career Fair, as well as the New Generation Trades Expo at the Agriplex in Surrey. FenCan members are invited to join us at these events. Sometimes it's free. So, you know, we're trying to get that awareness, come out and get involved, right? Meet and connect with a diverse community, including youth, newcomers, people that want to change in their career, people that are looking for something different. So these unique chances allow our members to recruit employees and showcase a wide range of roles and companies within our industry. So through this task group, we're working closely with our members, government officials, education providers, right? We plan to engage with the public through awareness campaigns, and we're working on social media videos to educate the youth, because we see that everyone's on their phones all the time and that their attention span is about this big. So they need to be short, quick videos. And so we've got a few samples today of some social media. These are kind of work in process. They've got some narration that's maybe going to get updated to include some bilingual, you know, French translation, because this is not meant to be a Vancouver thing, but a countrywide, you know, initiative. So without further ado, Terry, I'll get you to run a few of these sort of TikTok style social media bits. So obviously those are a little bit grainy, but they come through good on your phone and stuff. So I don't know if it's just the feed, but the idea there, of course, is to have quick sound bites, little pictures of, you know, glazers doing their work, with a link to the FenCan website. Because as we continue to expand our efforts, we want to point people at the job board that's been created on the FenCan website. So this is, in this way, we can put the employers and the employees together, right? We can have, there we go. And of course, this is still in its infancy, but here right on the main page is going to be a job board where employers can post their opportunities across the country. So this has just recently been put in place and still has a bit of work to go, but you can post a new job offer on here. You can give your job a title. The location is going to be important because if this is across the country, you're going to need to know what region you're in, the company name, the description, and your contact information, just like you see on other job boards. But this will be specific to glazing, and all of that social media and all of our campaigns will direct people to here, so that in that way we can get glazers in touch with employers. So I think there's one on here as sort of as a sample. There we go. So here we're looking for a drafting technician out of Mississauga. And you can put quite a bit of information on here. You can go as long as you want. You can have hyperlinks to Indeed. You can have email addresses for contacts so that the potential employee can reach out and apply for the position. 32 times, and not just you and I, right? So that's the idea. So this is just sort of the fresh initiatives that we're trying to put in place, but it's a good start, right? So we strongly believe that working closely with schools, career fairs, educators, some social media, we can inspire and encourage the next generation to consider glazing, right? Our efforts have been aimed towards breaking stereotypes, highlighting the industry, the benefit of having a fenestration career, and showcasing the various paths one can take within our industry. So if this resonates with you, please later on swing by our table to find out more. Come talk to myself, come talk to Rich. Otto's here on the task group. Geoff's here on the task group. Terry, of course. Come chat to us about that. Get involved, right? If we don't generate these, if we don't get a few Jedi stepping up, how are we going to get these Padawans, right? Where are we going to get these young learners? If thus older dogs retire out and the next generation isn't being trained up, these beautiful buildings won't be getting put together, at least not in the manner they should be. So they say you get what you give, and if you're ready to make an impactful contribution, give back to this industry, come talk to us about volunteering in the back corner. Thank you very much.
Thanks, Paul. Thanks, Brent. Good job, guys. Just a bit of an aside, sort of my perspective of where we've come from on the commercial side. So we launched, like Brent said, back in early 2023. Fenestration Canada has always had some commercial members that do crossover work, but more of a residential group for sure. We've seen about, I think, 60 members join us in the last year that are commercial focused members. Monthly meetings, we're doing presentations, we're doing educational content. So it's going quite well. We're really happy with the growth already and the participation. All the participation can always be better. And like Paul said, it's your industry. So please come and join us and help us boost the commercial side of our association. So we're going to get into the meat of today with our first session of the day. And we're going to invite Geoff Shellard up to do a presentation. So Geoff is with Guardian Glass. They have a table with us today. So thanks for that. Geoff was with PFG Glass 2015 to 2023. Actively presents both virtually and in person, presenting to architects, fabricators, glaziers in small groups, lunch and learns, as well as larger conferences and seminars to educate on products and help them select glass for the thermal performance and aesthetics based on prescriptive performance path. Geoff recently accepted a position at the FenCan Board of Directors as the commercial chapter's representative. So Geoff, come on up and let's get at her.
Pitter patter, let's get at it, as they say. Right, Amy? Not paying attention. If you're not paying attention, I will throw things at you. You better be writing notes, that's right. So this is actually really impressive that you guys all showed up here today, especially the fact that you only found out when you got here about the party afterwards, right? Right? There's still some empty chairs. They don't know. Be a big surprise for them. Bam. All right, so just to reiterate, my name is Geoff Shellard. I'm the Architectural Design Manager for Guardian Glass in the Pacific Northwest, which basically means that I cover a very large area. I cover Alaska, BC, Alberta, Idaho, Oregon, and Washington State. So there's a lot of parity amongst these states, but there's a lot of things that are incredibly different. As mentioned before, I've been in the industry for about 9 years. A lot of that time I spent working for PFG Glass. I worked for a fabricator. So I got to know the ins and the outs of glass manufacturing, how to supply glazers, how to talk to glazers, that sort of thing. And then moved over to this side of the spectrum, working with the actual product, the product that gets put into IGUs that then goes to the glazer and gets installed. So it's a fascinating industry to be on this side of the fence. So the learning objectives that we're going to go over today, we're going to talk about solar heat gain and how it influences our building designs. Talk a bit about solar heat gain in relation to our Guardian Glass products. Talk about sustainability and embodied carbon, right? These are buzzwords that are certainly circling around our industry. And not just in glass. I mean, it's every component of commercial, residential, almost every product out there. And then get into current and emerging technologies, including vacuum insulated glazing, right? So you want to stick around to the end to hear about this fascinating technology, which you may have heard about before. But again, this is a product that has not proliferated the market quite as of yet. And we hope to be an influencer in that. So one thing I learned from Fenestration Canada is, we went too far, is to have a liability disclaimer. So basically, whatever I say up here on stage, other than actual factual information, which you may or may not know is fact, is basically my opinion, right? I'll get to that part as we get into the new technologies, but there's going to be some numbers and things like that that are fact in and of themselves. So I can't even like stress this any more than I possibly can right now. Consult your authority holding authority holding jurisdiction, right? How many of you called up a glazer or a fabricator or somebody and just said, what is code? What am I supposed to do? And everybody kind of goes, I think it's this, right? That's not an answer. Vancouver's got the answer. Burnaby's got the answer. Your BC building code has the answer. That's where you should be referencing. All right, so a little bit of a history on Guardian Glass. We were founded back in 1932 as a windshield manufacturer. So when you take a look at the logo itself, the big G with the guy on a horse and a lance, right? He's protecting people. These were windshields back in the 1930s to protect military vehicles and the like. So of course we advanced our technology. We got into float glass, and in 1983 we added low E glass, low emissivity. From there, we moved into branding our commercial product known as SunGuard. So for those of you who are commercial glazers, you're looking at the SunGuard product. Then we put our first jumbo coater line in 2018 in North America, achieving sizes of 130 to 204 inches. And then we advanced it into super jumbo, which gets you to 130 by 240. Now, you're not going to make an IGU that size. Nobody's going to install that in a building. It's ridiculous. You're going up to 8, 10 mil, 12 mil at that point, right? No, it's your fabricators that love the big sizes because it helps with optimization, right? Better yield. You're not wasting as much glass, which helps with things like embodied carbon. The hamster did not get his coffee this morning. Yeah. So talking again about our product portfolio, starting with the SunGuard line, that's the commercial product that I represent. Moving over to ClimaGuard residential line, that again, fully residential. Into our interiors, we're talking about low iron, we're talking about clear glass, crystal clear low iron, satin deco, bit of spandrel in there. Our shower guard product, and then you get into technical and transportation. Again, windshields, you're talking about IGUs. You're talking about VIG that was used in Whole Foods for refrigeration doors, things of the like, even screens, television screens, things like that. So we've got our 6 substrates here that we effectively use. We've got clear glass. Everybody knows that one. Literally just weeks ago, we launched a brand new product. It's called Crystal Clear. I call it a near low iron because it is very, very close to low iron. If you think about it this way, ultra clear low iron has about 100 parts per million of iron. Clear glass has about 1,000 parts per million. So crystal clear has about 250 parts per million. It's a very nice neutral tone, and it's a less expensive, more affordable option if you don't quite want to go clear, but you really want that slightly more clear look, maybe 1% more visible light transmission. Crystal gray is our light gray substrate. A lot of schools like using that product because it helps to bring down the solar heat gain. Then you also have gray to really drive down the solar heat gain, take down the reflectivity in your glass as well, and then moving into green. How many people love green glass? Are we designing with green glass these days? Are we putting into our high rises, our homes? No, not really. It's not super popular these days, guys. So you might as well press it now. So Guardian coatings and solar heat gain. So let's talk about how those two combine to give you an idea of how they pair up. So if you guys are familiar with Slido, get your phones out and get ready to put in a code. How many do you know what solar heat gain is? All right, forget about it. Show of hands. How many of you know what solar heat gain is? Yeah, you give me. All right, so we got a good show of hands. That's awesome. So I'm going to run through this with a very deep breath and tell you the explanation that's on our website. Solar heat gain is the sum of the solar direct transmittance and the secondary heat transfer factor of the glazing towards the inside, the latter resulting from heat transfer by convection and long-wave infrared radiation of that part of the incident solar radiation which has been absorbed by the glazing. Thank you very much. So in more layman's terms, right, it's to influence the cooling and the heating loads in our buildings, right? It's to influence the occupant comfort in proximity to the windows, right? I live in a townhouse complex. I'm sitting by the window on a cold day outside, but I'm on the inside and I'm feeling really hot next to the window. Why? Because that sun's just hitting me and I need to move 2 more feet away from the window to feel comfortable. Then think about this little puppy here, right? 26 degrees Celsius in one room in our house. How are we going to achieve that? We're going to achieve that through heating and cooling, but we're also going to achieve it through the glass that we use to reduce our solar heat gain. Look at that big ball of fire there influencing us.
Yeah, it was.
Anybody see the eclipse yesterday? Of course not. We don't get that. We don't get the privilege of that. So I'm just referencing Energy Star here, particularly because I want you guys just to take a look at some of the numbers here, right? What ends up happening with the commercial industry? We're influenced by the residential industry. If you're doing a mid-rise and you want passive house, you want lower U values, things like that in the upper portion of the residential, what do you think happens to the podium? Sometimes it follows suit. Other times you're lucky you don't quite need that. But if you're looking up in Northern Canada, let's say you need something of a solar heat gain higher than 20, right? You want to bring in that passive heat because it's pretty damn cold up there. Then you got North Central and you're trying to actually keep it below 40. South Central and Southern, you want 23 below, right? Because it is hot in the summer. So think about what it's like when we have a heat dome over here. So think about this influencer. We got roughly, I don't know, a few days that we run over 30 degrees Celsius here in the Vancouver market. How many days do you think we're going to be up over 30 degrees when we hit 2050? It's probably going to double, if not triple. And then once we get to 2080, it's going to go up exponentially even further if we don't do something about it, right? So we're not designing for today or the next 5, 10 years. We're designing for what it's going to be like when we all get a heck of a lot older, right? Your kids get older, your grandkids get older. Thinking about what it is that influences on a commercial level. You know, Prince George and Edmonton, you know, they're not that far apart, and they're equally on the same map here. And that yet I got a project in Prince George that's a 0.66 solar heat gain, bringing in that passive heat. So that's how they designed it. But when you talk about, say, a project in Edmonton where they decided to really maximize the heating cooling load in this building, they wanted a lower solar heat gain. So you don't get parity prescriptive across the board. You have to move, you have to flux, you have to have products that work with the industry and work with you as glazers and architects. So I'm just going to run through real quick some of the products that we have just to give you a sense of what it is that it means when we talk about solar heating and how these products react to this sort of thing. So a bread and butter product that we have is SunGuard Solar Neutral 68, SN68. Commodity product, right? Everybody's got something like this product. They all run in and around a solar heat gain of 0.38 with clear over clear, U values 0.25. You can bring that number down by putting it on a light gray substrate, like crystal clear, and then drop it down even further on gray with visible light transmission between 34 and 71. So this is a product that, from a dual IGU standpoint, do you think this is going to stand the test of time? Right? Do you think we're going to be putting this in our residences? Not really. I think we're going to put it in our commercial. Do we want that much heat coming in? No, we want to try and drive that number down. So where you see a product like this going is it has to move into the triple sphere, where the triple sphere paired with something else can bring the solar heat gain down. But then what do we do after that, right? We move to the next slide and we go to our next product, which brings the solar heat gain down. And it is called, drum roll please, SNX 6227. So it's kind of in the name there, right? 62% visible light transmission, 27 solar heat gain. So now we've brought it below 30, right? It's getting a little bit more comfortable in that space. We bring down our solar heat gain again by putting it on different tinted substrates. And of course, each tinted substrate brings down your visible light transmission. So of course, when we design, we have to be aware that we get these different trade-offs between visible light and solar heat gain. We move to the next slide. Notice that U value doesn't really change much, 0.25 to 2.24 when you're dealing with a single low E coating on surface number 2. I'll get to the slide that brings the number down. We talked about our new product, SNX 70 Plus, which we launched back in October. Again, view value 0.24, that's redundant. Solar heat gain 0.27 on ultra clear low iron, our new crystal clear product and clear substrates. And what's great about this product, it has a high visible light transmission, but a low solar heat gain, right? So that's great technology, and it actually maintains this color off angle at 90 degrees, 45 degrees. But this is kind of where we see products going, right? You're trying to now manipulate the coatings in order to provide all this visible light, which we want in these certain applications like residences, and keep that solar heat gain down. Let's move on to the next one there. So this next one is called SNX 5127. And again, 51% visible light transmission, 23 solar heat gain. I got a sample sitting over there on the table. It does look darker, has a little bit more of a bluer tinge to it. But if you're trying to bring down glare, that's why you'd use a product like this. If you want a slightly blue aesthetic, you might use a product like this without moving to a blue tinted substrate. Again, you're going to get a solar heat gain of 23 on that. You're going to drop it down as you move along. Look at that, 16 on gray. Now think about this. If you're in Southern California, anybody know how many climate zones there are in California? Throw out a number, 10, 15, 16. I think it's about 16 or 18. So think about how Vancouver's got its own code, and then you got Burnaby. How far apart are they when you're standing on boundary, right? Not far at all, but two different prescriptive codes. That's like California. You can be on one side of the street, you need a 0.22 overall U value, or sorry, solar heat gain. You're on the other side of the street, and maybe you're at 0.29, right? So products like these are going to start to get more common as we start to drive this solar heat gain down using tints to drive the numbers down. We'll go next slide. So getting into the reflectivity component of our products, solar heat gain of 0.29, again, that's under 30 on ultra clear and low iron. This is a reflective product, gives you still a degree of visible light transmission, but look at the numbers, right? 34 to 50% visible light transmission. When I worked with products like SN68, comparable products, I was all about, man, 68% visible light, that's where you want to be. So when you see something at 50%, do you think it's got a lot of light coming in? It actually does. Not as much. It's got a reduced glare to it. But when you're on the inside looking out, if you look in any building, do you think it really diminishes the light by that much? Is it that much darker? No. No. So we can't be afraid of these numbers because this is where a lot of the numbers are going to go. We'll move next slide. Move into the next SunGuard SNR product, which is SNR 43. How many of you are familiar with AG 43? Right, I see some hands, right? That was a cool product. A lot of people loved it. Then you know what we did? We pulled it, which made a lot of people not so happy. But you know why we did that? Solar heat gain, right? We're taking a product that's super popular and we're saying this just doesn't cut it anymore. We're not going to be able to sell this in our market because we need to drive those numbers down. So what do? We advance to the next product. We come up with SNR 43. Solar heat gain at 23. Again, you can drive that down when you get that all the way down to gray. Get a little bit dark at 22 and 45% visible light transmission. We'll go next one and we'll get into SNR 35. That's our more highly reflective product, right? Cool thing about it is not a tinted substrate. It's just clear glass with different layers of metal on it to manipulate the color, manipulate the solar heat gain, manipulate the reflectivity. Ooh, it's slow. I'm way ahead. Maybe we'll double tap past that. That's okay. If it goes one more, that's fine. We'll just skip past that. How pretty is that? Look at that reflective glass. Hey, all right. So I'm talking about all this low solar heat gain. Then what do? I throw up a slide on here that has 78% visible light transmission and 65 solar heat gain. Who wants that in their home? Give me a round of applause. Yeah, crickets. All right, where do you want that? You want it up north, right? Maybe if you design that way. Again, maybe you design your commercial building to allow that passive heat to come in to reduce your heating load. But what happens when we hit winter? Is it going to be comfortable or not? You don't know. It has to get modeled that way. You have to determine it. Now, you get high visible light transmission. This is great for podium, retail, anywhere where you've got a lot of doors are just flipping open and maybe you're not as concerned with it. You want that visible light. You want to invite people into your space. But where you see a product like this replace is in a triple IGU, where you take the clear glass out and you put this in. And you know what that influences? It influences your U value. So it can still be a product with a high solar heat gain. It still serves a purpose, but you have to pair it off with something else to, again, keep those solar heat gains down. You guys recognize this building over in the North Shore? Yeah, he does. All right, let's move to the next. Yeah, is he a long way around? like the government putting out our BC building codes. Anybody in the room from the government of British Columbia? Okay, I'm safe. All right. Yeah, I know too late. So SunGuard IS-20. How many of you think that fourth service low E is a swear word? Well, that's good. I like that because if you're in Seattle, it's a swear word, let me tell you. They're pushing that hard and they're having a difficult time with it. We're a little bit more accustomed to it here because we've seen it in our residential products, right? In commercial, people get a little bit scared of it because who's the first person that's cleaning that glass? Is it a third-party cleaner? Are you familiar with them? Did you pay them a contract or somebody pay them at the lowest dollar to come in and basically take a Brill pad or some steel wool and scratch that drywall dust off there or whatnot? Yeah, so a product like this makes great sense to bring down that U value from 0.24 to 0.20, but you have to make sure you're picking the right fourth surface low E coating. Some are a little bit, as a friend of mine would put it, they're a bit of a princess, right? They don't like to be touched. They don't like to be looked at. But then when you get to some that are a little bit more durable, right? They wear a hard hat. They come to work every day and they will withstand scratch. They won't scratch. You can clean them. Great for commercial environments. These products are necessary for you commercial glazers to stay in the dual IGU zone without having to jump it over to triples. Then when you throw it in a triple, now you're getting to the passive house end of the spectrum here. So we'll bring to the next slide. It also is pretty damn close to clear, so it really doesn't impact your solar heat gain or your visible light transmission. Bird-friendly glass. You guys think that impacts solar heat gain? Well, it's already on the screen, so I've given it away here. But products like Bird First, UV coating, etch, even frit, these don't impact the solar heat gain. The spacing of the patterns is 2x2 or 2x4. So they're not influencing the solar heat gain until you take frit and you put it into a 40% pattern or a 60% coverage. That can influence your solar heat gain. What does influence your solar heat gain is when you take that coating and you move it from surface 2 and jump it to surface 3. Depending on the product, you can see your solar heat gain jump 8 points, or sorry, yeah, it'll jump 0.8 or 0.11. Fact of the matter is if you've got a target you need to hit and all of a sudden you design it with Frint on the outboard and move your low E to 3, your solar heat goes up, you didn't hit the target now. Now, of course, maybe if you're lucky and you're averaging everything out, you're okay. But if you really got to hit that target overall, then it might take your numbers down, and that becomes a bit of a concern, right? So just be wary that if you talk to the fabricator and they say, I'm going to move your low E to 3, ask them why they're doing it, ask them if it's going to impact the overall system, and then work together with them. Don't work apart from them. Don't work in a silo. So let's talk about emerging technologies, stewardship at Guardian Glass. So again, getting towards the embodied carbon, the operational carbon end of things. Show of hands, how many of you have seen an EPD show up in a specification? Okay, so a few hands, right? It's about the same answer everywhere. A lot of people aren't familiar with it, but you need to become familiar with it because it is going to influence every piece of component, every aspect of your job site. Now, it can start from whether or not it's rolling out on your interior partitions, cabinetry, anything with VOCs, whatever it is. But when it starts to hit glass, it's going to hit hard, right? So I'm going to talk a bit about the Environmental Product Declaration, the EPD that you'll see out there. So it's the information about life cycle environment impacts of our product. So the first thing we see in this chart is A1. A1 talks about the raw material supplies. That's your silica sand. That's your dolomite, your rouge iron, your salt cake, soda ash. Those are the things that we put in the batch to create the glass. So then you get over to your inbound transportation. That's transporting all these materials to our flow plant. And then, of course, the transportation within the facility. And then you have the manufacturing component. Now, how many of you are familiar with how flow glass is manufactured? Throw some hands up. So we got a few, right? So I'll give you a bit of a 101 on this real quick. Take all these ingredients, you throw them into a batch. You superheat them to 2,900 degrees. You melt it into a nice big vat of lava. Then you basically let it cascade gently out into a tin bath where you have some candles and some nice port wine. And basically it's just sitting there floating along until it comes out as a nice sheet. And you're going to cool that down until you have a nice solid substrate. You're going to give it a visual inspection, make sure it's A-OK, meets ASTM standards. In our case, half of ASTM standards. Then we're going to chop that stuff up. We're going to send it out to our fabricators, or we're going to send it off for coating, and again, put our low E coatings on the product. That makes up the A1 through A3. Once you get beyond that, you're into operational carbon. That's basically what's happening in this building right now, how they're running the building, how they're repairing things, different things like that. If you take this glass out here and you decide today, we really should have put bird-friendly glass in there because look at all these big imprints of birds that have impacted the building. Now we got to get scaffold. We got to get a boom lift. We have to apply something to it. Or God forbid we say, tear it all out, put more glass in, right? Mistakes like that cost a lot of money. That's operational carbon. Then what happens at the end of the life cycle of the building? Probably tear it down. Unless we do an adaptive refit, right? So if you tear the whole thing down, can you take all these materials in a life cycle and put them right back into something else? Some products you can, some products you can't. Glass is one of those products where it's really, really hard to take it and recycle it because these IGUs, you have to take them apart. You have to take the glass apart from the hot melt, from the silicone, from the PIB, from the spacer, and you can't just throw that into a vat and hope your glass comes out okay. What do we get? Nickel sulfide inclusion. Oh, it's a real nasty swear word, right? So we're trying to avoid things like that. So talking about the EPD, which again, now Guardian Glass is a North American company, but our glass plants here, we have 7 glass plants in the United States. So they have to appease the General Services Administration. So the United States primarily uses a 100-year GWP as a measurement of the relative impact of greenhouse gases. So I love this name, U.S. General Services Administration Inflation Reduction Act, Low Embodied Carbon Glass Requirements. You know that a politician made that up. So GSA IRA limit for low embodied carbon glass in kilograms of carbon dioxide equivalent per metric ton. So our flat glass GWP was 1,455. We dropped that to 24% and came up with 1102. Nice thing about that, that puts us in the top 20%. That means we actually have the lowest reported GWP in North America right now. Now that's going to change because everybody's evolving, everybody's changing, everybody has to keep up with the times. Yeah, just skip past that one. Again, I wish Slido was working for me. It's good questions. There's some good humor in it as well. Again, moving at the pace of government. So let's talk about emerging technologies in glass. What's next? Right? So this has always been a fascinating topic for me because as you know, since I got in the industry back in 2015, there's been different things that have kind of come and you hear about it, you get excited about it, and then some things kind of, you know, whimper out, some things evolve. How many of you know of thin or skinny triples? Yeah, there's a few. Yeah, I know, right? The two of you, obviously, it's very clear. It utilizes an ultra thin center light, typically between 0.7 millimeters and 1.3 millimeters thick. Now I point this product out because again, new-ish technology. Kicker, it's more of a residential product. But if somebody's coming to you and asking you for it, it'd be a pretty good idea to understand this product. So you're taking a look at this IGU, you can see this little slot in the middle of the spacer. You stick effectively your Corning architectural glass technology in the middle of that, and it creates a skinny triple. The idea is you'll be able to take a triple IGU and put it in roughly the space of a 1-inch overall or just a dual unit IGU. So if I'm just running this with 4 millimeter ClimaGuard with 6227 surface 2, and I'm using a 3/8 inch spacer, which in the commercial industry is my glass going to touch? How big is my unit? I'm afraid of that. I'm probably not giving you a warranty on that. So now we get into this product, which is a lot smaller. And why is it also smaller with the 3/8 inch airspace? Because I'm using Krypton. How many of you have deep, deep pockets? Probably not a lot of you, right? So you're probably not putting Krypton in there. So this already pushes you out of the realm of commercial glazing because are we all interested in basically spending as much money as we possibly can on our storefront? Probably not. So great numbers on this product, but am I going to pay a heck of a lot more to use a smaller space? Am I going to make it up with my framing system? You might. That's not my realm of expertise here. But this is just kind of showing you the difference between these two technologies. So we will move to the next slide. It's actually kind of cool. It's taking a little slower because this is all the really cool stuff, right? It's like, oh, the suspense is building. How many of you heard of aerogel? Yeah, all the people with hair, right? I have not heard of aerogel since I was a young teenager, let me tell you. But taking a look at these U values, overall systems, 0.30, 0.40, and then double IGU, less than 20 in a triple IGU. And yet I can do a 6 millimeter IGU. That's just full of aerogel, right? So this is great for retrofit. This is great for taking out that 6 millimeter unit or just piece of glass and retrofitting with a better thermal performing product. Here's the catch, though. Again, this is where we talk about the disclaimer, the opinion part of things, right? 2020, they did a pilot plant. 2022, industrial production began. Did you do that? Let's see if I can pace it between bells. 2022, industrial production began. 2024, not an LBNL. Add a field for haze, right? So now you're looking in LBL and you're trying to determine, how do I model this? And even if aerogel's in there, do we add a column that says there's haze in my glass? I'll wait till they pull me off with the thing, right? So haze will be a factor. Haze will have to be concerned with. So that's why you're probably not seeing this on the market just yet. Maybe they're trying to dial that in a little bit better. I call this the tick glass segment, right? You've got electrochromatic, you've got thermochromatic, you have photochromatic, electrophoretic, you have systematic, automatic, hydromatic. Who's filling in the next line for me? Thank you. It's not karaoke hour. I'm not singing. Pat Flannery was here and he put me on the spot. So again, just look at all these options here, right? You've got
Geoff. Sorry, it's just the hotel alarm. It's a false alarm. So
not a glazing contractor.
I love the way everybody got up and panicked and ran out right away.
Yeah, we're all used to this on the job site.
What is that?
right? So moving just quickly through this stuff, right? Electrochromatic, you've got lithium ion. You're moving to things like viologens, chemical dial, and nanocrystals. And thermochromatic, you're basically responding to heat. Photochromatic responds to sunlight. Electrophoretic, light modular ELM, sounds like a band, right? You're basically being able to go down to a 0.2% VLT up to 70% and modulating your IO radiation, again, talking about solar heat gain. Next slide. Geoff saw this on the plane, the Air Canada plane, I believe. Where is he? Yeah, there you go. Pretty cool, right? That's right. Press the button. Tick, 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 tick. Yeah. Smart glass, photovoltaic PV, and building integrated photovoltaic BIPV. This is a crazy thing, right? So we talk about what we use today: double IGUs, triple IGUs, double IGUs with a forced surface low E coating. Maybe you're adapting things with LAMI, things like that. Now you try to get into this realm and look at this laundry list of options or things being invented or things that may or may not come to market. I showed you the previous slide with the 4 different options. Then I show you this one. Now you tell me which technology you're going to jump on board with. How do you make a decision? How does this product get to market, right? Is it Blu-ray or is it HD disc? Is it beta or is it Betamax or whatever it says? But you can see, right? You've got to pick something. You have to move forward with some sort of a product, like we move forward to the next slide. Segue. Oh, I did sing. Emerging technologies. How many of you heard of metamaterials and meta surfaces? Good. How many of you heard of AI-driven smart glass facades? You've heard of it. I'm sure you'll probably all hear about it in a week. Google will come out with something or whatnot. And then aluminum oxynitride. 2015, transparent aluminum came out. Wasn't that cool? I was just like, that's the first new innovation I ever saw. And I was like, well, there's no way this is going to market. It's way too expensive. And you know what? It probably never will come to market for any form of glazing application other than to stick on missiles or space shuttles, things like that, because it's Star Trek glass, guys. This stuff's incredible. But again, how do you bring something like this to market? It's too expensive. So we'll go to the next slide. We'll just get about ready to wrap it up here, folks. Which leads me to the future technology of vacuum insulated glass, right? VIG. You've probably all been hearing about it for years. Guardian dipped our toe into it from 2016 to 2019 based on 20 years of research. At 2019, we realized we got this great pilot line, but again, cost, right? So what do? You put things on pause. You hold on and you wait to see where the market goes. You see whether or not this is going to be something that we as an industry all want to use. And you know what? I asked this question of a bunch of people in a conference. I said, what do you think is going to be the first place in Canada that's going to want to have this product? And I was thinking, God, it's got to be like Montreal. It's got to be a place like, with older universities, places where you have, you're doing retrofits, right? How about we just go up the street to Vancouver, right? Who wants to be the greenest city in the world? Who wants to have a 60-story passive house high rise? This is the kind of product you want to put in there. Right? We just started a 10-year partnership I can say it by rote. 10-year partnership with Velux, who does skylights, who does roof windows. And it's a 10-year partnership, not a licensing agreement. So we're sharing our intellectual property to effectively come out with this product. And by the end of this year, we're looking to start manufacturing our VIGs in Denmark for that skylight industry, and then eventually work towards scaling it up for general population, right? So it's been fun coming on board and having people talk about this product. And then all of a sudden, I look online and my company goes, hey, remember we talked about VIG a while back? Well, we're bringing it back. So full a ton of information, tons of innovation. I've got oh, wait, what does this I have in my pocket here? Oh, it's a VIG. Wow. It's not as big as the one at the opposite end of the room, but it gives you an idea of what we're talking about here. Very, very thin, right? That's the idea of being able to retrofit buildings with something this thin, and then put that into a hybrid unit and really start to see our glass, our insulated glazing, go from being the worst performing part of the facade into being part of the facade that's not so shabby, right? If you're R20 for a wall and R40 for a roof, wouldn't it be nice to have something that comes a little bit close to the wall? We'll move to the next slide. And the next one. And that's basically it. So if you guys want to scan my barcode or come see me, by all means, feel free to come talk to me. Hope this has been informative, educated. Again, if you have any questions that go beyond the knowledge I just gave you and talk about building codes, things like that, go talk to your authority holding jurisdiction. Otherwise, come talk to me about the products that we have. And again, thank you for your time today. Appreciate it.
Thank you, Geoff. Okay, we're just going to take a couple of minutes and see if we can fix our bit of a lag that we've got going on here. So if you want to grab a quick coffee or something like that, feel free. And we'll be back with Don Welch from TORMAX in just a few minutes. So I got earlier when we were doing the intros, I got caught up in thinking about my finger, and I forgot that I had promised Matt Marshall from CAD-PLAN, one of our newest members. He's got a short video on their product, and he's going to just do a real quick blurb about who they are, what they do. So this is Matt Marshall with CAD-PLAN.
So good morning. My name is Matt Marshall. A little bit about me. I represent CAD-PLAN North America for their technical sales and support. I've been in glazing for close to 10 years, started on tools, did the APAR, did the PM stuff, found my niche in drafting. And so CAD-PLAN supports two softwares. The first and most, our flagship, is called Athena. And Athena started with enthusiastic drafter, and the whole point of it was to make drafting easier and less burdensome on their, obviously, drafting companies. So we have a standard parts library, and our profile systems are entirely customizable by anybody that wants to use them. We have 2D tools that obviously make drafting quite a bit easier. And we'll see here in just a second that 3D tools are even better. Every time we've shown the 3D tools to experienced AutoCAD drafters, my favorite comment is, "That's amazing," because we can generate our drawings from 2D into 3D up to LOD 450 if required, ready for direct CNC export. And we also will integrate with even people like the Rainers guys. So we do have a bunch of integrations built in. You can see this one is fairly easy. All of your machinings, all your glass, all your sheet metal. So we have over 30 years of experience doing this, and we support somewhere around 15,000 individual licensees internationally. I'm the sort of technical guy for North America. Our next product, which we'll see here in just a second, is Apollon. Apollon only has about 4 years of development into it now, and it is based on Inventor, which means that we get to leverage the capabilities that Inventor has, such as parametric drafting. Parametric drafting is important because it allows us to, you can see that's an export to EuCAD right there. Really, really easy. I was just at a client yesterday who was doing the same thing. Sorry. Apollon, yeah, absolutely leverages the capabilities of Inventor. And so we're a drafting company. I will give you the training. That's the main point here, is we can take you from an AutoCAD only drafter doing 2D fab drawings, 2D shop drawings, bring you right through to the CNC fabrication. And we have customers that are doing this in under 6 months. So again, Inventor's super cool. We all know it. We all like it because we can do things parametrically. We can get bill of materials out. No problem for both. Your glass cut sizes, automatic. You don't really need to worry about it that much. That's what, like, everybody's takeoffs, they take a lot of time. I understand that. I was a drafter, and fab drawings take longer than they need to. Draw it once, use it every time. That's what I want you guys to be able to do. There is a QR code up here if you want some more information. It will also get you a demo version. I have a pretty distinct mustache, so if you see me walking around, feel free to stop me, and I will be happy to have a conversation about anything sort of software related, or more specifically, yeah, drafting and design software. Perfect. Thank you.
Thanks, Matt. All right, so we're going to get into our next session. I'd like to welcome Marie Jimenez from Sherwin-Williams to intro this session. Give Maria your absolute attention because it's her Visa card that's coming out for the beer and wine at the end of the day. So, Maria.
Thank you, Terry. Please join me for a drink after the show. Not now, after the show. The next presenter, Don Welsh from TORMAX Canada Inc., has an impressive career with an operations management technical diploma from BCIT in Burnaby, BC, and an MBA from the University of Alberta School of Business. Don's career spans 34 years in the building products industry, specifically in facades and windows and doors. Having spent 14 years in the commercial storefront and curtain wall glazing industry, with 6 years specific to automated entrances, while opening and facilitating branch operations in 4 separate provinces, BC, Manitoba, Ontario, and Quebec. Without further ado, please welcome Don Welsh as he presents the update on automated entrance code requirements in Canada, door options, and evolving industry trends. Don?
That was quite the intro. Holy smokes. While that's going on, I just want to tip my hat to the previous speaker, Geoff. The amazing work to go through and not even skip a beat while the alarms are going off. My hats off to you. We've got a few learning items. Thank you very much. So we've got a lot of content on these slides, and I promise I won't read every line on it. I'll let you guys do some of that work. I just tried to give you some background to what I've learned in the last 6 years to get into this automated business. Okay, so some of our learning objectives, obviously, I'm just going to give you a bit of an introduction to the entrance automation, what that means. Just a couple of slides on the Accessibility Canada Act and how it influences everything. Obviously, some local code interpretations, all the hierarchy, the ADAM program, specifying project requirements and some of the pitfalls and whatnot. And also just a general overview of some of the other automatic door types. And then a couple of observations on what I think is coming up and new in the industry. Okay, so we talked about my topic having something to do with commercial door, and it certainly does. We don't necessarily supply the swinger doors. We automate other people's doors, the glazers' doors. We do add on our technology, our sensors, our components. We also do supply our own sliders, revolvers, and whatnot. But I just want to make it clear that we often get confused with overhead doors by the general contractors for some reason when they talk about the realm of commercial. We are more specific to the automatic door industry. And again, all of our competitors typically automate other people's doors, but we may see that change in the future. There it is. So the major benefits or the overarching benefits of the automated entrances, obviously accessibility, energy efficiency, and of course the safety. The biggest one, of course, is how people with disabilities, vision impairment, people carrying big loads, whatnot, our doors help that and make that more convenient, certainly more accessible. Also, the energy efficiency, we're finding that as we crank down on the facade performances, one of the last ones that have not been fully regulated or measurable are our commercial doors. They're designed to be open a lot, so there's a lot of air changes. So we see the market or the industry trying to figure out how to measure and improve that. So we want to be a part of that. And then, of course, the safety is just we need our automated doors not to harm anybody. And certainly see things where our sensors get out of the way from people or objects. Oops. Okay, so I thought I'd throw a slide in just to talk about the growth. We see significant growth in this part of the industry. Obviously, a few things are driving that demand, but it looks like it'll double. Most of the forecasts that I'm reading, it's going to be doubling by 2030, 2031. So that's a pretty extensive growth per year. That might even accelerate in years to come as the industry adopts more of our newer components and products. So the biggest thing, obviously, is the cranes in the sky. General growth in Canada, project development, especially the big multi-use, Oak Ridge, some of the other big ones in every major city, that drives more automation just by plain design traffic. But also specifically in our world, this Accessibility Act that they adapted a few years ago, barrier-free washrooms and whatnot, we're seeing a big influence now on the design characteristics because they have to be more generally accepted in all projects. And so there's a real shift in my mind that designers, architects are adapting these concepts a lot faster. Also, the inspectors are inspecting or enforcing these codes earlier in the game now too. So obviously we talked about the net zero passive house indirectly with our facade, but we're also seeing across every province. We've got branches in Brandon, Manitoba, Ottawa, Ontario, and Quebec City. So we're seeing in all provinces a real major federal government and provincial government spending on their healthcare infrastructure. So by its design, there's a lot more automation projects available. And then also we're seeing a real shift to the access control and different understanding or expectation for security with some of the societal changes coming up. There we go. Okay, so I've got 3 slides on this. A lot of you guys may already know this. I'll skip through them fairly fast. But when I was researching how our hierarchy of codes came about, I was shocked after being all in the industry all these years, the actual influence of the Accessibilities Act. And so it becomes the overarching driver for certainly for our business. I didn't realize it was impacted or written into the the societal demands right from the United Nations conventions, the Canadian Charter of Rights and Freedoms, etc. And so the ACA starts to build up this program and the systemic approach defining the barriers. Okay, I am not going to do what Geoff did and read that whole thing out as fast as you can. I put it in there just to reflect because I, as a Canadian, didn't realize how broad this act was in terms of deciding what a barrier is. So I also didn't understand that this act also covers just access to the World Wide Web, internet access and whatnot, all communications. So I put it in there because obviously Canada is trying to adapt it and has got a lofty goal of 2040 for full-on accessibility. So it's to me, it's I was surprised by it. We do see an increased focus and now a growing enforcement in the building inspectors side on all the tools and measuring the Accessibility Act. Okay, so the one thing about it, the ICC ANSI 117.1, that is harmonized standard. It's the basis of the whole program for us affecting the entrances. It's most effective in the federal side of things for the federal bureaucracies, government corporations, etc. Again, 5 of the provinces have adapted their own version of the Accessibilities Act, and several others have got process going on. Alberta is trying to figure out whether they are going to launch one. Apparently, Saskatchewan has one under review. Quebec is a different beast a little bit. They've got this patchwork, but they certainly are aware that they've got to clean all that up. I think Quebec is more respectful on their heritage buildings and a lot more older complexes, and so they're a little afraid of what they have in their old building stock. Okay, so now you get into your regional aspects. Each of these major cities, and I think a couple more by now, have their own interpretation and design building design guides. So that also comes into play for our regional. As Geoff had said, you got to worry about your regional bodies, governing bodies. We're also in BC. BC Social Housing, of course, has got its own interpretation. And Rick Hansen Foundation is certainly trying to take entrances, but the whole barrier-free aspect and make it more mainstream. So those are impacting us as well. Of course, we talk about the fire codes, the various Burnaby versus Vancouver, Ottawa versus Toronto. They've all got their own interpretations of these various levels of acts. So we've got to take that all into consideration. So the ADAM certification, we'll talk about that a little bit more. Some of you probably already are aware of it, but I've got another slide that gets a little bit more in detail on that. But the major takeaway is, despite us having a visibility on what the codes are, we still have to be aware of what that local authority wishes to enforce and wishes to interpret. So we have to be aware of that prior to doing all the work, of course. Okay, so I'm not going to read every single one of these, but you can see from the commercial doors and automatic entrances, there's a truckload of compliance specifications that we have to build into our designs and our package solutions, our site solutions. The more common ones are the 156.10 and 19. Those are the most common, but we've also got to pay attention to the national fire protection and just, what those local governing bodies want to see in terms of fire exit code. Okay, there's more specifics on the 2 main ones for swingers and sliders. Again, I won't go all the way, but the difference mostly for low energy and high energy is low energy was based on the fact that the old-fashioned spring-loaded or regular door closers had to have a certain force for the average person to be able to operate it. So our low energy automation takes some of that work and has a low energy code specification, if you will. Most of the doors these days are approaching high energy. So sliders are taking over for a lot of the high energy supermarket stores. Used to stand on the mat and the door would open while you push your cart in. A lot of those are being taken over by slider packages and different versions of that. Speed, convenience, a little bit more control in terms of the access. But you can see there's a lot of bullet points within this decision criteria on how you, pick and comply with the particular codes. Okay, again, I won't read every line item. The idea of the ADAM, with the American Association of Automatic Door Manufacturers, got together several years, probably back in the 80s and 90s, and decided they better come up with a bit of standards or a package of codes so that they could self-regulate themselves. Now, of course, that's grown into the governing body down there. Up in Canada, they're not, it's not mandatory yet. In the US, they're more litigious, so they need these guidelines from a legal perspective. We're seeing a very significant move to the ADAMs, and most of our competitors, along with ourselves, are adapting these. Just number one, well-being of our own people and our own liabilities, but just the fact that there's an ongoing training and certification program that you can keep your technicians and whatnot up to speed with all the changes. Yeah, so we're several of our competitors also offer ADAMS training. So if you've got people that are in the business, There are more Canadian-oriented training sessions for this going on. The Atom, of course, is specific to the automated door industry, but you know, we're trying to spread the news that it's a good way of keeping our technicians up to speed. Okay, so I've got a couple of slides here that are just bullet points, mostly to the design people or building owners, trying to figure out how to pick some of this or how to get in front of, I need an automatic door for my building or my store. There's lots to consider. Again, the biggest complaint or the automatic doors today are still fairly expensive. They're a significant investment. So you want to take the effort and the understanding up front to pick the right solution, the right products into your particular application. Obviously, if you pick the right one and install it correctly, then you're going to have a long life cycle. What you don't want to do is spend a bunch of thousands of dollars and put it in wrong or not have the right application and then fight City Hall or not operate or not last for very long. Automatic doors should last, you know, 5 to 20 years if they're done right and chosen right. Some of the important factors when you're designing is, you know, the automatic doors have got to be almost idiot proof. People have got to be able to walk up, intuitively know where to go, and the labels have got to be there so that they can, you know, almost protect themselves against the door. But the door has got to protect them more than the human has to protect themselves. Again, the appearance is important to any building owner, but it becomes second or third tier beyond the life safety part of it. Again, all local codes, right, to the glazer packages or glazer contractors, all local codes still have to be researched and understood and signed off on. Okay, so see, these are 2 slides here. I've got a couple of bullet points, just things to consider. Most important is it going to be used as an emergency exit in a case of an evacuation? Does it meet the fire code? It doesn't, you know, the fire codes get interpreted by region, but it's got to manage that. Most of the doors today have to have a physical breakout in North America. That's you know, the door. The dumb humans are going to run into the door and the door's got to burst open. In Europe and other parts, they don't break open. They assume that the human will know what to do with the door. North America, we assume that the human will panic and need to get out in any event. So our products are a little bit more complicated. They've been on the market for a long time. They all work fine. It's just that when you're designing new products, you've got to take that life safety aspect into your design. Another thing that's becoming more and more important is, do they have to be locked or have controlled access? We all know what's going on in the downtown cores and, you know, some of these changes in society. And there's other influences that we didn't have to consider in the years gone by. So nowadays with bigger complexes, unfortunately, we have to figure out how to keep the inside safe and whatnot. Different products for different application. The biggest one is what's your traffic flow? What do you expect? High traffic, low traffic. The types of pedestrian users, people with shopping carts, more people with wheelchairs. You have to take all that into consideration. Obviously the opening, whatnot, the aesthetics of the building, it's got to look nice. It's a big investment. It's got to look nice, but the other stuff superseded, if you will. And then another one that you guys have talked about a little bit here is the energy efficiency. It's growing bigger as we speak, especially driven by the City of Vancouver. And this is just life cycle expectations. If you, you know, pick the correct product for the correct application, you install it, plumb, level, and square. Keep the maintenance up. A lot of entrance doors don't get maintained to the level that they should. So we've got a service side, and I can speak from experience that you know, the door's not working, but it haven't been looked at for 3 or 4 years, and you've got ice melting materials and you've got gravel. So there's wear parts on these things for obvious reasons. Keep that up, and you're going to have a long life cycle on these products. Okay, oops. Okay, just a generalized view of, sorry guys, of the types. I've got some slides, quickly go through them all to show you the various types. They all do different things, have different performance expectations. Most common are swinging, and slider, but now we're seeing a return to revolver doors. They were big back in the 70s and 80s, or kind of more monumental types of approaches, but because of the facade piece and the green build and whatnot, we're seeing more of them come back into play. Yep, wrong one. Okay, so the telescoping slider is just another version of the regular side slider, if you will. But this one's got the 3 arms or more that all telescope up. From my perspective, it has its use, but I'm not fussy about them because they take a lot of maintenance. Okay, so in an opening that you've got lots of high traffic and you want that door to open up as quickly or as in control as you need it to be, it's a perfectly good application. We shy away from them because they just take a lot more maintenance, and the building owner understands, and he gets impatient that we've got to come back and change wear parts faster. There's more parts moving, as you can imagine. They work perfectly well, by the way. Okay, so there's all glass versions. You guys have all ran into some glass doors. The Europeans are trying to do with no aluminum or steel surrounds. They're all complete glass with patch fittings hanging off of those things. I don't think our codes would take it yet with vandalism and the access physical breakout requirements, but the architects like it. They want more glass, less metal, less substrate. So we're seeing more and more. Obviously, my other picture is more of a manual door. But the idea is it's the one that can transfer that to natural light the easiest. They run perfectly well. It's just that I'm not sure that you want to put it in your front door in this Canadian climates. Another slider version is the ICU CCU door. Lots of them going in, especially with the healthcare investments that I spoke about. Every hospital needs hundreds of these things. What we are seeing in the marketplace, some of our competitors have automated their versions. We've got ours coming out as well, just for some of maybe the operating rooms within the ICU, wheeling people in and out of their heart surgeries. Another thing about it is that they can be lead lined, or glass can be put in there to manage some of those X-ray transfers and whatnot. So that product is growing, in my estimation, just with the spending going on with the governments. Okay, this is the more intense version of the ICU door, and this has got the 3 or the 4 seals. Very European. Other competitors have them as well, not just us, but they snug right up against the wall system. They have to be installed very, very carefully. We're starting to put them into these specific departments in the hospitals. The biggest thing is that they control the negative the negative airflow, or can be lead lined. Well, Geoff did a real good job of entertaining you in between technical glitches. Yeah, I don't have any jokes right now. So the hermetic doors I'm seeing growing in application. They weren't readily available in North America until a couple of years ago. So I'm seeing, again, TORMAX is European held. Assa Abloy's got a lot of European influences, et cetera. A lot of the competitors are now European, and and their designs are impacting North America. The collision between the architectural desires and the new technology is colliding with the physical breakout aspects. So in my own company, the European designers don't really understand the North American code, so we have to translate for them all the time. But the hermetic door that you saw first was one of those versions that it absolutely makes sense in some of these hospital laboratory applications, where we've been considered for the Royal BC Museum for their research and their development building coming up, their staging, if you will. So they want to keep some of those artifacts with the environmental changes very minimal, so that these types of doors are coming and they're readily available.
While we're trying to sort this out, got kicked off for some reason. Questions maybe for Don? Anybody? No? He's explained it all.
Yeah.
Go ahead, Otto. I'm going to give you a mic.
Like a vestibule or a road, what do you call it?
Yeah, absolutely. We're seeing more return to vestibules and even mild Southwest BC here. Vestibules are very, very common in the prairies. The most cost effective, the energy efficient is the revolving units because you've got your controlled cabins. It's never fully closed or never fully open. So you've got a predictable cabin amount of a volume of air. So, but they're also the most expensive. So the sliders by their nature open up. And so if you're not controlling that open and close because maybe you have 3 or 4 people walking in and you've got that air transfer going through. You try to offset, make the doors opposite in a vestibule. You can't always do that in a retail environment where every square foot's expensive. So I see those vestibules now as turning into more mixing areas so that air gets mixed in with the interior air.
So with the revolving doors, do they work with pressurized air or anything like that?
Well, there's nothing inherent in the there's nothing inherent with the pressurized, but because the door panels or the door wings are always touching, it's
never,
again, you can predict it. You can measure it and model it. Whereas the other doors, it's just tougher to model at this point. So
there's nothing newer than that, really.
Nothing newer than that. Now you can introduce air systems, conditioned air or heat systems, to air curtains, if you will. So I see them coming back, certainly in the colder regions. Ottawa and Ontario, Toronto are adapting or returning to those air curtain applications. So we can build them right into our products now and start to control or assist the control of the air changes. So
cool. Thanks.
You're very welcome.
Anybody else?
Come on, Randy.
So Don, what's your service to a glazing contractor? Like, they're working on a project, they're bidding on a project, and there's some automated door systems. Do they just call you and how does that process work?
It depends on the stage of the project, if you will. Typically, the bigger ones are already been thought through by the architectural firm, and that's all been specified or reasonably specified for what their intentions are. If a glazing contractor contacts us, and not everybody wants to take on the automatic scopes, if you will. So we get both, that the contractors can't find anybody to take it on, so they just come direct. But the glazing contractors that want to embrace it, then we can be their full service partner and help them interpret the specifications, make recommendations. Not always are the specs clear, as we all know from those hardware cut and paste opportunities. We get the same thing in our business as well. So we'd rather be partners to the glazers. We'd like to get involved as soon as we can, so we can identify any things that conflict with their facades.
Yeah, if it's not something you're familiar with, get a professional to help you.
Well, and the fact that you get to the very end and you've got to have occupancy in 2 weeks, that's too late for us. We got to deal with what's there then. So to have the best control, the best solutions, get us involved earliest that you can in the project. Good question, by the way. Well, I don't know if there's a clear rule. I mean, it's defined where they have to go. But if it's a full sensor one, it's still got to be a knowing act, if you will. So there's a difference between a low energy needs the knowing act. You need to activate something. So now the human is equipped with, okay, I've got to be aware that there's something moving. Buttons on a fully censored device, you may not need that if the sensor senses somebody coming towards it. So you've got to be more specific with your application for me to give you the one answer. But today, and we'll review it again a little bit on the what's new. But Ontario has had this up-down or the column switches so that people in wheelchairs or visually impaired can hit the bottom button now and activate the door rather than find the one that's at waist height. So we're seeing more of that. And so depending on, like, Vancouver and British Columbia are now adapting that. So now they're really enforcing what type of buttons and what kind of conditions relative to that opening. And we are seeing, it's been in the code for a while, but now we're seeing full enforcement. Even Oak Ridge, for example, were on there, and they were just single buttons, and they thought they were grandfathered. But no, we've got to go back and have either column switches or up down, so that the City of Vancouver is no longer grandfathering these things. They're going full into enforcement. But yeah, if The condition and the solution has a button. There are rules and measurements relative to accessibility, wheelchair to, pardon me, can get around the door to get in on a timely basis. So there's positioning is important and height and whatnot. There's rules. I don't know if I answered your question. There's a lot of data there. One more question, yeah. Well, every general contractor runs their sites their own way. I would love to get like a steel door. You have standard ROs. I would love to see us adapt standard ROs for our business. It would cut down costs and project delay. But a lot of people, glazers, will give you what's left over. General contractors measure it and order it. And if it takes 16 weeks, we'll just yell at you at the end. I'd rather embrace some standard openings. Unfortunately, we get what's left over. We're near the end. Just get it done. We've got occupancy in 2 weeks. So it's a good question. There is processes. The good general contractor versus the disorganized one. You get that in all parts. Regular residential windows are part of the scope is no different. But yes, if I could write a process, I would love to give it to them. A lot of the big contractors, like an Ani, for example, they know what they're doing. Just get out of their way. Do it when they said to do it. Okay, so we're back. Good. Okay, I promise I've only got a few more slides and we'll wrap this up for you. What I was trying to point out about this is, I didn't touch it.
Are you kidding me?
Okay, well, you see the stainless steel cladding in beneath that particular photo in Europe was lead lining, and we've got different degrees of lead.
Really?
The door leaf is heavier than heck, but we can manage the X-ray rooms and whatnot. So that is something that we're seeing lots of interest, especially say in Alberta healthcare. They're going through some changes. They're going to spend a bunch of money. They're very excited about that door product. I'm assuming with the flurry of announcements in BC, we'll get asked about it kind of at the tail end of some of these large jobs. But it's a newer product to North America, but it's nothing Star Trek-ish, but we're very excited about it. We bring that in from Switzerland. Our competitors, again, we're supposed to be a little bit neutral here. Our competitors have a version or two. We think we're the leader at this point, but our big competitors have got their product, and I think they'll be bringing it into the marketplace as well. The biggest thing is just that the slide development, the slide mechanism that opens and closes, but sucks itself in and controls the seal. So again, all of our capable competitors are all working the same way. They're reacting to the same bullet points of what's happening in the market. So obviously hands-free. We talked about sensors. So there's a lot there. Through COVID, there was a real push to go to the hands-free, the wave action. But people soon figured out they're still touching handrails and pushing buttons in elevators. So what are we doing here? When it's a convenience-related item, we see those wave to open. But more and more, it's not so much about hygiene anymore. It's just more about convenience. Okay, am I pushing? Okay, good. I can blame somebody else. Okay, so the folding doors, we've got a very nice folding door, but it doesn't have the physical breakout. So we're trying to figure out how to take our European, British build and bring it into this market. We initially, when I first joined this part of the industry, I didn't see the need for the folding doors, but what it is some of the smaller openings that really they weren't automated, but now need automation, and they want to put a little bit more traffic through. There's a real need for it. So the problem with the North American product is because they've all have to have the physical breakout. They're quite rickety. Okay, so again, fully functional, fully practical for that particular application. But the folding door is one that does its work, but it's a maintenance hog. And we've got to find a way to design these things up, especially as our group is going further into the east with the older buildings. They've got smaller openings. In Europe, that's, those old heritage buildings, they put a lot more sliders in right on the streets. So we see a need. I just don't like our they're too rickety for me. Revolving doors, we bring ours in from Denmark. A lot of influences from Europe on these. They were big in the downtown cores, casinos, big fancy buildings, monumental. things, and then they kind of went dormant because of the climate. They're expensive, blah, blah, blah. We're seeing a real renaissance, if you will, especially in the east where the climates are cold. I'm sorry. And, you know, and they come in manual, they come in push to assist, also fully automated with security features and anti-backpacking, etc. So there's, I don't know, probably 8 or 10 different ways you can do them. The smaller the compartment, the less expensive it is. The bigger, of course, you get quite up there in terms of expense. But because of that energy efficiency push, we're seeing a real interest level even in downtown Vancouver, where it's pretty mild all year long. So we haven't sold one in Vancouver, but they are here, and the designers are getting more interested in it. Okay, so this is just some of, I won't read it all out, but again, we talked about cabin size. So those in between the wings, you know, in a 4-wing, there's 4 cabins, 3-wing, 3 cabins. And so we can give the designers or the RDHs of the world some formulas on how much air changes so that they can bring that back into their modeling for the total facade. Again, just because they got a better model doesn't mean the building owner wants to spend the money, but that's where it's going. I honestly believe that we're going to try to figure out the formula for sliding doors. You know, there's a push to understand that. It's just very difficult to do because by their nature, they're meant to be open. Okay. One other thing that we've determined by accident, obviously, is just the Hyatt in Montreal, sorry, Hyatt in Quebec City, had a significant back pressure, stack pressure from the inside, and their doors were blowing open. And of course, it's one of the top hotels in Quebec City. And so we haven't put it in, but we've researched putting these things in for them because they've got a building stack pressure. Their mechanical system's just creating too much inside pressure, and their doors aren't operating correctly. So the revolvers help to control that in many places. Yeah. It's funny. I have in restaurants where their big fans are sucking the exhaust. Not on our products because typically the mechanisms can handle that. But it's interesting you say that because I bet you on some of those buildings that I haven't seen myself, they've got to have that problem. That's right. Well, that's the one I'm referring to is the elevators coming down and creating that pressure to blow the doors out. So the opposite could take effect for sure. But in restaurants, often you can't open the door. That's exactly what's happening. Those exhaust fans for the cooking are pulling too much air. Oh, did we lose it again? No. Very close to finish, guys. Very close. Right. Okay, just some of the other industrial doors. So this is still in our automated doors, but they're commercial doors. A big push for some reason in California for these European style 4-door steel-built doors, and now Quebec City, or Quebec, the province of Quebec. So for whatever reason, the regional influencers are really liking this type of product for, you know, their high use ski hills and whatnot, but most importantly, fire halls and city halls and things like that. Expensive, but they don't fail. Okay. So bigger applications, obviously aircraft hangar applications. Some of these sliding folding door systems. And then this is off the channel. That was a European, British, French. They needed to have these emergency evacuations that can withstand, you know, something on fire or something blowing out, and they can close these doors. So these heavy duty industrial doors are starting to come into North America in a limited fashion because they're so expensive. That aircraft hangar door is probably a $600,000 door. So the, you know, people, making those decisions, that's a bit of an eye opener for them, but they have their places and their needs. And I think it's going to be fine. This is the what's new. I'll go through it very quickly. Washroom packages, you're starting to see them show up in BC. They've been the standard in Ontario for all the years I've been in this side of things, 6 or 7 years. But I'm seeing them now, restaurants, especially Starbucks, whatnot. We're busy running around putting these washroom packages in. So what it is, it's an assistance, automated door, but there's an alarm system that somebody's in there with a disability, falls, or it needs some assistance. There's a dignified way to set off an alarm that somebody understanding the humanity of the situation comes in and just assists that person. So you're going to start to see some of these show up. Certainly in the City of Vancouver, we're seeing that more and more. But it's a standard in Ontario. It's coming here. I haven't seen them in the other provinces yet, but Manitoba seems to be paying attention now for whatever reason. And you know, in some of their government buildings, we're starting to see them there. But that's coming for sure. The up-down activators, column switches, we talked about that a little bit. We're seeing that more in all provinces now. 38-inch doors. You know, obviously the standard's been 36. Us boomers are getting a little bit wider, need wider wheelchairs. So I didn't realize it till I started working in the Ontario, but that's a standard out there for the wider wheelchairs. We are getting more and more commentary that it's likely coming here as well. So from my experience is Ontario typically sets the pace on their Accessibility Act. BC closely follows. Vancouver trying to then take over the lead or the innovation part of it. And then the rest of the regions and the provinces follow suit. And as I pointed out, Manitoba, for whatever reason, I'm not doing anything for 25 years. They're on fire now with their government infrastructure spending, and they're trying to adapt all these accessibility rules. The emergency throw bolts was a new one. Some of the downtown core retail stores, you know, put their automation on their doors, but they want, you know, to fire a button if they've got something going on in the street, keep their staffs safe. Now the technology is there, but it's not necessarily working properly, but it's coming, that you can throw an emergency switch and lock down your store. So that was something that was just 6 months ago we ran into that one. Biometric access controls, eyeballs, obviously, you've seen it on some of the movies. It's there. It doesn't make cost effective sense, not yet in certain buildings. What we have been involved with is trying to design up a keyless building that once you drive in to your parkade, you park in your spot, building knows who you are and where you typically want to go. I don't know if they're going to be able to make it work in a cost effective, but the fact that they're designing these things up to see whether or not the end user wants to make them use, put them into, you know, spend the money, the investment dollars. I'm assuming sooner or later there's going to be a high net worth building that wants that type of extra protection and concierge service. And then finally, we talked about the revolvers going to come back in a bigger way. So that's kind of it. Thank you very, very much. Excuse the technical glitches. If you've had some questions, I'm happy to ask.
Yeah. Other questions for Don? Anybody?
No? Yeah.
Hey, Don, you kind of touched on it with Anton and with the Hyatt comment. With like manual doors, I've seen lots of complaints related to mechanical system, air pressure, air tightness, popping sounds and stuff.
Yeah.
And I am wondering who is the party, because now that they're codified forces for accessibility, who's overlooking that? Or are there troublesome spots? I know that probably your system can overcome it quite a bit, but you know, like you said, the entrance to a hotel, is there spots where like who do the glazing manufacturers talk to say, you know, we've met the code requirement when we've tested in ideal circumstances, but now we've got this particular thing. Who's supporting the glazing manufacturers?
Well, very good question. As you can tell, to get the building into occupancy, you've got your building inspectors that say, yeah, you've met all the terms and conditions and the design criteria. After it's been a couple of years, you run into exactly those types of conditions. And I'll be honest, I don't think there is anybody but the good honor of the service people. I would say that the ADAM program, if we could more fully adapt that, that is a voluntary program, but I think it balances the field between all competitors, and it gives those individual technicians giving out that advice some real grounds, some real guidelines on what to promote. If it gets very complicated, then we'll bring in our design engineers or our own technical people and try to give a site-specific solution. But there is no governing body that measures all that, unfortunately.
Sure. And are there problematic areas that you see consistently, or is your system just dealing with it that it doesn't?
Well, again, the biggest problem is if you've got somebody that's wanting a cheaper version, so they took a lower grade device and put it in a high wind or a front exposure that the wind just catches that door. So we see that somebody's trying to understand, well, I spent, you know, $2,000. Why am I trying to replace it? Well, they put the wrong unit with the wrong strength in the wrong situation. And then we talked about the back pressure on some of these big buildings. If the stack pressure is out of control, it's kind of hard for the door guy at the very end to try to do anything unless, you know, it's $100,000 revolver going into it or something. But we can, you know, our industry have pretty smart people behind the scenes. So any one of our competitors, you know, pick me, but our competitors are all very worthy as well. They have people that can go in and offer more site-specific solutions.
Well, I just, from comments that I generally hear, is the door's too heavy. That's why it's having a hard time opening. And so often I'm like, well, the exact same door is actually down the street and doesn't have any issue. So,
and I thank you for that comment. That just means that likely it's underpowered or somebody's chosen cost versus performance.
Yeah.
But it's not for sure. No.
I've never heard of that before. Anybody else? Historically, always aluminum products. Are you seeing any new technologies that are going to bring different substrates, maybe it'll fiberglass or composites or anything like that?
Well, we're all in the same parts of the industry, so we're seeing thermally broken aluminum showing up more, so we can automate thermally broken doors. I don't think there's any magic substrate for us at this moment, but our product, and I'm certain our competitors are doing the same thing, is the RDHs of the world or the design people are looking for thermally improved solutions at a cost-effective investment. And so we're very aware that the market's going to shift and they're going to want our commercial heavy-duty doors thermally improved. And so we're, you know, our new slider coming out, I don't know when yet, in the next few months, I hope it's going to have the ability to be thermally improved once we get it launched. I think our competitors are trying to find thermally improved solutions. And if that is just some of the higher end aluminum that we're seeing here in this situation, we can automate those doors in that application. But we also can do fiberglass doors. Typically, you know, that, you know, cost versus investment or cost versus benefit we don't see it showing up in fiberglass doors, but the fiberglass part of the group is gaining out there in terms of thermal improvement.
Okay. Anybody else? All right. Thanks, Don.
Thank you, guys. Appreciate it.
So we are a tiny bit ahead of schedule. Lunch is coming up probably in about 20 minutes or so. So I'm going to encourage you to visit our exhibitors, grab a coffee, hit the loo, whatever you need. And we'll be back after lunch with Sean Pander from the City of Vancouver. And is Sean here? Put your hand up. I think we're going to have Sean Pander from the City of Vancouver after lunch. So lunch will be out shortly. Enjoy, and we'll see you in a bit. All right, folks, we're going to get back to it here. Hopefully everybody enjoyed a little snack lunch there. Potato salad was particularly good. If you had that, it's great. No? Yeah, that was good too. Yeah, it was good stuff. Okay, so lots of interaction with our exhibitors. We really appreciate that, as do they, I'm sure. But I do ask that if you are visiting our exhibitors during a presentation, please try and keep your voice down. There was a little bit of interference. That's what threw our Wi-Fi off earlier. So today with us for our next session is Sean Pander. Sean Pander is with the City of Vancouver. I didn't bring my notes, so Sean, I'm going to let you talk about what you do there. I know you're big on the green side of what Vancouver is doing, and talk about Vancouver's energy codes and all of that. So I'm going to leave it to Sean to dive into what's happening in the City of Vancouver. All right.
Thanks all. And yeah, my name's Sean Pander. I'm the Green and Resilient Buildings Manager with the City of Vancouver. Very active in the city as well as the province in sort of advancing and modifying the structure and requirements of building codes for energy performance in buildings. So I'm here today to just tell you a little bit about, how those codes have been shifting, what those implications are as I can see it for the fenestration industry, and then maybe some of my guesses about what might happen next in that space. So I have to confess, I am not a architect. I've never designed a building.
I just can't hear you very well. Maybe hold the mic or lean in a bit.
All right. I thought there was a bit of feedback, so I'm
Oh.
okay leaning in.
Okay.
Get as close as possible. There we go.
There.
Okay. So, yeah, I'm not an architect. I do not design buildings. And I am not an expert in fenestration, design, installation, construction, but I do know quite a bit about codes, and so I'll share a little bit about that. I'm actually really thankful, Terry, for the opportunity, though, because I love sharing where things are going. We like industry to understand, what's changing, how it's changing, and then understand the kinds of questions and interests that might generate.
Yep. Just takes a second. Oh, too far.
Bit of a pause there. Okay, so really there's two main drivers, two things driving this sort of fairly rapid evolution of energy codes in BC in particular, but the similar changes you'll see sort of ripple out across the country. And the first is just this growing concern around climate change. The climate is warming. That's going to have fairly significant impacts for folks. And so more and more so, and I think what you'll see in BC, there's the Clean BC plan, which has set out very ambitious targets, but has quite a number of regulatory and programmatic steps to reduce provincial-wide emissions. But similarly, many of the local governments in BC have adopted a climate emergency declaration and plan, and that indicates, they want to take space at or take action at the local level to begin reducing emissions as well. And we'll talk a little bit more about how provincial versus local government actions relate, but they're not exactly the same. And then, but also one piece that's emerging in code development is a growing concern around the impacts of climatic change. So the climate is changing. And I think the heat dome of 21, the heat dome of 21, we had 600 fatalities in the province. Over 100 were in the city of Vancouver alone. And I think that was a real wake-up call that the climate is changing quite significantly. And that is causing quite a bit of health concerns as well. And so I think what you'll start to see gradually, and I'm just giving you guys a forecast of not only are we trying to, improve window and fenestration performance in terms of thermal heat loss, but there's going to be this growing attention on how the window systems can help mitigate heat gain. Okay, who here has heard of the BC Energy Step Code? Okay, thank God. We actually invented the Energy Step Code in the city of Vancouver in 2016. And so here we are 8 years later. And yep, okay, generally people understand, but I was quite surprised. It took quite a while. And so, just as an overview, the BC Energy Step Code is a new way of regulating energy in buildings, and it's being adopted across local governments in BC. And so, Vancouver has its own charter, so we can write our own building code. We're not attached or constrained to the provincial code at all. And that allows us to innovate. But what other local governments saw and the province saw was the way we were trying to innovate, the challenges we saw around the way energy was regulated nationally. It wasn't going to get us to the deep greenhouse gas reductions that our politicians and citizens in Vancouver wanted. And other local governments said, yeah, we see that same thing, and we want to change how we regulate energy use. And so the province said, okay, we're not giving everyone the same authority as Vancouver, but what we'll do is we'll create a code structure where local governments can opt in at different levels of performance above the base code standards. So those are the different steps. So you might, you'll have different steps of performance, and just pick a building type. I'll focus on high-rise MURBs, or high-rise multi-unit residential buildings. And, you know, there's 4 steps of performance, and local governments can opt in at sort of just a very junior step, a higher step, and then that step 4 is sort of like, oh, this is like a net zero ready energy building. And so local governments opt in, and then that becomes the code requirement in that jurisdiction. So, you know, you would think, oh, it's an optional thing, local governments opt in, but over 70% of new floor area constructed in the province is now regulated by the energy step code and not the basic premise of the provincial code itself. So the local governments have been adopting it. In particular, the more urbanized ones have been adopting a step and then moving into higher and higher steps, higher and higher performance requirements. So, as I indicated, TEDI is, it's called the thermal energy demand intensity, but it's really, if you just think of it as a metric of net heat loss, annual net heat loss. And so I say net because it does take into account, given the occupancy type, there's some internal heat gains that happen inside a building, right? Like in a commercial building, an office, or a retail building, you have a lot of internal heat gains, high occupancy loads, high equipment loads, used to be lighting, but you get a lot more internal heat gain. But largely for you guys, I think just think of this as how much heat is the building losing. So it's a measure of its thermal insulation, I guess. And so net heat loss. But you know, the things that are happening here in BC now with the step code, but the types of changes, this focus on envelope performance, you're seeing it, you know, sort of spread out across the country as national codes pay more and more attention to this as a way of regulating energy use. And part of that reason is again, many of the policy drivers are climate change. And within that, you know, wanting to go, oh, most of the greenhouse gas emissions in a building, especially in Vancouver's sort of, or in the national higher population provinces, is driven by natural gas combustion for heating. So this is a real focus. Let's address this primary issue, the primary source of greenhouse gas emissions for buildings. So, you know, a couple of the main factors that impact how a building's TEDI, thermal energy demand intensity, or net heat loss, you can look at its, you know, how much skin area is there for the amount of floor area. And that really speaks to how articulated the building is, right? Like, I mean, think of a window. You can have a window that's really tall and skinny, doesn't necessarily have a lot of area, but it has a lot of perimeter, right? Like, so it has a lot of potential for the building, a lot of that extra skin area given the amount of floor area. So a really complicated building will have a lot more heat loss because it has a lot more walls and a lot more potential windows for heat to escape from for a given room or a given unit. Of course, the glazing industry really doesn't have a lot of control over that, but that's a variable that happens. And, you know, what you see is you get super simple buildings, just a box. That's like a very simple, you know, that's the sort of perfect form, closer to a box you can get in terms of heat loss. But the glazing ratio, so the amount of, you know, window area to floor area that you see within a building. So that glazing ratio is window area to wall area, total wall area, is a really important factor that indicates how much heat loss, because generally the walls are better, you know, lose less heat than the windows. And so the amount of window area you have is a big factor in your TEDI performance. But it does also how the windows meet the walls And so that, sort of that perimeter area, a lot of that, the wall heat loss is at the detailing of where it meets the windows. So that perimeter area of your windows also impacts the teddy. And then obviously the window U value. Some of the other factors, of course, are the how airtight the building is, how much sort of draftiness or air leakage you have, as well as now almost all buildings have something called a heat recovery ventilator. So how efficient that the thing that controls the stale warm air leaving a building, that a heat recovery ventilator preheats the fresh cold air coming in. So you sort of, we've heated up all this air, instead of just letting it go out to atmosphere, let's use it to preheat the air coming in. And depending on how efficient your HRV is, that'll affect your teddy. But really, I think the thing to focus on within fenestration, glazing ratio, sort of the thermal bridging potential of how the window units meet the building walls, the window performance itself, and then again, a bit on air tightness. Again, the detailing and how easy it is to seal a window into that wall are all factors that affect the thermal energy demand intensity. Okay, don't be scared. We're gonna have this one twice. This is just a tool that's available if you guys want to sort of see for yourself how these various factors that impact the teddy, how they might change. And this tool is called Pathfinder, buildingpathfinder.ca. It's a free online tool that was developed to enable all industry players and developers get a better sense of like, what are some of the choices. And in this tool, you can fix certain variables and just say, okay, I'm not playing around with like how complex the building form is. I'm not playing around with the roof insulation. You can just fix some numbers and, it suggests some defaults, or you can use some, you can change the default and you just set it. And so, the example I have here, and we'll go through a couple of what these lines mean, because it gives you sort of a better understanding of the implications of the U value of the window on what kind of teddy outcomes might be achieved. But, you see on the left is this is just a typical shape or typical form factor, again, how much of that wall area you have. The glazing ratio, this is a 50% glazing ratio multi-unit residential building example. The wall R value, the roof R value. Again, the main thing we're playing with in this is to show how codes and window performance are beginning to relate is the window U value. And then we've fixed the other variables, and then it shows the range of possible teddies that could be achieved by that building, depending on the U values that are chosen, assuming all those other variables are established. Okay, so that was just a little intro to the tool. It is a really helpful tool if you want to understand, I'm going into a jurisdiction, they've adopted this step, that means the teddy is, whatever that number is, and then what kind of glazing, what's that range of glazing options? Now, again, it's not the only thing you can control. A developer will play with those other variables as well. Like they'll have designs and have higher R value window or R value walls. They might go to higher or lower glazing ratio, depending on what kind of market segment they're trying to hit. So again, it's not the only variable. But this one here just shows an example. And I've got a pointer here. If you were well, let's just pick this midline. So this kind of fuchsia, I don't know what, light green line. So everything's kind of fixed. It's all fixed. R value is fixed. And if your window, this is an imperial measure, 0.3 U value for the window, what that would lead to is you follow that and you get to roughly a teddy of like 29.5 or 30. And that's a pretty good window, right? Like in terms of a multi-unit residential building, a U value 0.3 and a teddy of 30. 30 represents sort of the next to final step. So almost the highest level of performance, that you can, local government can adopt. And so that 30 is a number of local governments have adopted already. And again, in this window, and these other numbers that I'm showing you here are quite typical numbers for the other variables. So, you're looking at, if you're in a jurisdiction that has a TEDI of 30 in climate zone 4, I guess the other thing that really impacts TEDI is how cold is it outside. So that's one example, and that gets you to that TEDI of 30 number. Now, in the city of Vancouver, because we're special, we don't stick to necessarily exactly the step the same structure. But in Vancouver, the TEDI requirement is for a high-rise MERB is 25. So if you find 25, say, here we are. We've got to be on this dark green line. So you follow that one back. Now you're into a window U value, 0.26. Right. So for this building, if you don't change the glazing ratio or any of those other factors, that shows you the kinds of window performance that you're going to require in these high-rise MERBs for the other variables. But it gives you a rough, TEDI 30, unless people are going with a really radical different design for some of those other variables. That's kind of the nature of window that you're looking at. Now, some of the implications are fairly obvious, like this new code structure and this new focus. There is a sort of a gradual decline in overall glazing ratios. When we began this work in the city, if you looked at a typical high-rise MERB in Vancouver, or probably any high-rise MERB in climate zone 4, sort of the southwest corner of BC, in MERBs, you used to see 55, 60% glazing ratios is very, very common. This is just those were the glazing ratios we saw. I think now you're seeing 50% as a lot more typical number. And even in, higher end, some of the higher end ones are going down to 45% glazing ratios. Now, obviously in low rise, you don't have the same window wall assemblies. You just got the punch windows. You have lower glazing ratios. But it gives you an idea of why glazing ratios are declining. Obviously, the growing demand for high efficiency product, like looking at not just the glass, but also looking at the frames and the frame design. And then, as we've already alluded to, sort of this, maybe not having a whole bunch of very tall, skinny windows, which have all of this extra sort of heat loss through the frame or where the frame meets the wall. And then, also implied in that is how easy is it to detail for air tightness on those, as you put the window in place, if it's not already integrated into a window wall assembly, but if it's a punch window, how easy is it to integrate the air tightness? So, obviously, but coming with some of these changes, some of these pressures, quite a significant economic opportunity. This was a study from the Vancouver Economic Commission. It was done, it's out now, actually quite old. It's about 5 years ago, but it's the last big study of adoption of the energy step code. And, they looked at it and saw that now it's not all windows, obviously. There's, there's more jobs in terms of the detailing. There's other types of equipment that go into meeting the energy step code, but a lot of it's about the wall assembly, the insulation, and the windows. And they forecast sort of between 2019 and 2032 a $3.3 billion economic opportunity associated with these increasing standards. And so, it just points to, there's some pressures, but there is an opportunity here to sort of, as you're trying to get ahead of the market, but you've also got a higher value product that you can sell to these projects that are required to meet these new codes. So I alluded to in my introduction, but one of the other pressures, and you haven't seen a lot of regulatory action in this space, but it's beginning to emerge. I get to see it day by day, and I'm involved in it. But climate change, in terms of, as we're talking about it, we're going to see warmer winters, right? So how hard it is to meet a teddy will gradually become easier and easier as the winters get warmer and warmer over time. Now that's going to be a slow change. So, I wouldn't come out with a brand new product counting on, us having San Diego weather anytime soon. But, that's the longer term forecasts are looking at, like by 2100, Vancouver will have San Diego climate. So again, the type of thermal performance will change. But with that, we're going to see a lot more frequent and a lot more intense heat waves, like the heat dome indicated. We're going to start seeing that as a lot more normal, and it's going to become a growing public health question and concern. And the codes and regulations will start to respond to that. Now, I also put increasing smoke events on here because not so much that you would think, oh, what can my window do about, forest fires? Like it's not, okay, maybe if you're at that interface zone, there's a combustibility question, but more it's a question of, when are we going to have smoke events? That they will probably start overlapping with extreme heat. So we want to keep people cool, but we don't want smoke getting in. So we're going to have these airtight buildings and people are going to want to be able to stay cool with their windows closed. So yes, you're starting to see the rise of mandatory mechanical cooling, but you will also start to see, a lot more interest in how does the sort of the glazing, the low emissivity, requirement, which sort of keeps some of that heat from getting in the summer. How does that interface with the desire to minimize the heat going out in the winter? So there's, a lot more interest in low E glazing. I don't know where dynamic glass is going. I can't anticipate that market for you, but all these questions about what kind of coatings are on the glass, probably you'll start to see on the buildings quite a bit more sophistication in terms of the glazing design to respond to the aspect. Oh, north facing windows, a lot more heat gain or less heat gain if you face north. Oh, you're facing east and west, which are the sort of challenging directions because the sun is sort of at a lower angle in the morning and evening. That's when it can get in, it's directly overhead. You don't get a lot of sun coming into the windows. So again, just the design will start to probably consider the aspect, and you won't get just a uniform design and a uniform spec for the entire building, but it'll start looking at the different aspects. And then probably, especially in the commercial buildings, more and more designers looking to integrate maybe some shading, some fins, some of these external devices that, especially as the sun is, sort of in the evening or in the morning, that may prevent direct sunlight falling on the windows. And then, how much operable glass and where that operable glass is placed. We used to see, if you did get operable glass in a condo, you might have a window and it might be down here. Well, the heat's up here, right? Like opening the window up here doesn't get rid of a lot of the hot in your unit. And so you probably see a shift of where we have operable windows, that operable factor being higher up so that the heat, that higher amount of heat can escape more easily. I'm great. Thank you. So really, that's just a kind of an introduction to how those codes are changing. I think what you'll start to see, especially in BC, is a slowing rate of change. That the Energy Step Code, that thinking is now permeated across the province. The steps, governments are progressing up through the steps. But if I were to guess, especially in a high-rise MERB, are we ever going to get where the final step, a Teddy of 15 is going to be normal? I don't think we're going to see that because, that's going to push in a high-rise MERB. You'd have to go into triple glazing. If I had to guess, I don't think you're going to see a lot of jurisdictions go that far because doing a window wall with triple glazing adds a whole lot of extra complexity cost to the construction industry for sort of diminishing returns in terms of energy efficiency and thermal performance. We've already hit on, sort of a growing emphasis on managing overheating. And so really, that's how codes are changing. It's not just in BC. It's a different code structure nationally, so in different provinces, but you will start to see more and more this focus on the envelope performance and therefore the glazing performance and the details of how those windows interface with the wall assemblies. So I hope that was informative, and I'm happy to take questions.
You mentioned $3.3 billion opportunity, 1,695 jobs in energy, understanding or working with energy codes and stuff like that. What type of jobs are we talking about there? What kind of opportunities?
Well, I didn't do the study. I think a lot in terms of the jobs, it would be. I would only be guessing in terms of, I don't know your market in terms of if you're manufacturing here, are you seeing a lot of opportunities for export to other jurisdictions that are looking for high performance glazing? I do know, that's one thing as you go to the super high end of performance. We used to do a lot of work with New York, and they used to complain, oh, to build this super high performance building, a passive house building, we have to go to Europe or Canada to get our glazing systems. And when they said Canada, generally they were talking BC because that was the only place you could get that super. So that would be a factor that goes into that number.
So opportunities for export is what you're thinking, but are you talking also about like thermal modelers?
Yeah. So that it looked at professionals and the extra design time to take this into account, that expertise. It's not just here. You see this sort of trend across North America. The construction jobs, detailing a job for air tightness, for example, takes more effort. The heat recovery ventilators are getting more and more efficient. So it is windows, insulation, the design that goes into them, the value. It's a higher value product that you're trying to get into the market.
Yeah. So I wouldn't mind seeing some more information on that, just to understand if that's an opportunity or if that's a cost, or both. I mean, I'm assuming it's an opportunity for some people and a cost for others. So
yep.
Could be.
What I'll do is I'll follow up with Terry, and we'll see if I can. I'll get a link to that study. I know the author of the study, and I can help create an opportunity for you to understand what was included in that analysis.
All right. Thanks so much.
And if that was 4 years ago, that's 6.6 billion today, right?
Yeah.
12 billion.
Yeah.
Anybody else?
You touched base on air tightness a little bit in your presentation. For some of those buildings that are complete and going through the air tightness testing, and if they fail, what would the City of Vancouver would do? Like in terms of providing permit and then allowing them to get an occupancy permit and all that. If they fail and within the range that it's not totally not acceptable, but it's not meeting the requirements that they said they're going to meet. Like I've had a buildings that fail, but just given the options, like, hey, you got to do better in the next time. Is that where we're going?
Yeah, generally what we're finding is the industry's been responding good to the air tightness requirements. We don't want to have a major draconian approach to that because, again, the response has been, if you've, taken it into account, you've tested. Obviously, what we do is, you fail, we go, okay, what can you do to remedy? And then you could grade. Now there's a scramble on site to go, where is this heat loss? And you might use thermal cameras or smoke to determine, okay, can we fix this? Obviously, improving air tightness after the building is near complete is, you have limited options, but you can look for those. So that's typically is like, okay, you failed. Okay, let's have your envelope engineer identify, okay, great, here's where it's failing. Here's what we could do to improve that number. And the city is more and more going to expect you to have pursued all reasonable opportunities to pass the test. And then usually it's just, okay, I mean, I'd have to go to the engineers that are working on the enforcement side. I know on the low-rise side, we require, okay, you've got to go to some training and understand how to do this better. On the bigger buildings, it's a little bit different because who do you train? But it is what we've been finding, and we don't, it's interesting. There's a big lag between code adoption and airtightness testing. The code comes into effect. People are starting to design their buildings, seeking permits, getting permits, all the foundation work. And, there's quite about a 5-year lag. So we have a limited data set, but of the current airtightness requirements, 75% of the buildings are exceeding in terms of performing better than the requirement was.
Is there the threshold or line where you say no, this is not good?
On the
Something
high
like that.
rise, yeah, we'll probably get there. I mean, if you're failing that bad, it means you weren't even trying. And where we get to with that, that's going to be a conversation. We're not seeing that yet, so we haven't come up with how hard could this be. I know in the detached homes sector, though, we have been enforcing it quite a bit more rigorously in terms of, we started requiring standardized labeling, and, we now in detached homes or low rise, we require actually 2 tests, pre-drywall and post-drywall, because if you're not close to passing before you put the drywall in, you're not going to pass after you. It just gets worse from there, typically. And so, we require 2 airtightness tests. But what we found in the window space is, we started to find, that we've been signaling, you've got to have the label, you've got to have the right label. If you don't have the right label, we might make you tear the windows out. We signaled that for quite a while. And then we started going, okay, you don't have labeled windows, they're coming out. That. So generally, we're not trying to penalize people. We're not trying to enforce the code. We're trying to facilitate compliance. And so usually we try to signal, pay attention, we're watching. Generally everything's happening quite good, great, or no sometimes. And then what happened there, of course, is, the builder was like, what? Like the implication is on the builder. It's his schedule's thrown out, how he's lined up all his other trades is all thrown off. And word gets around, don't buy windows from those guys, because they told us it met code, but it didn't. We had to tear the dang things out. And so, it's 1 or 2 bad examples sends a pretty strong signal, because the market itself then starts to self-correct. That's not a reliable window provider. They said it met the requirements. Obviously a design team or a developer isn't going to test the windows directly. They're going to take it. Oh yeah, here it passed the test. Here's the label, whatever. So.
Anybody else?
A question I've been wanting to ask someone like you for a long time. My understanding of the STEP code, and Teddy, is that it's based on set environmental boundary conditions that are averaged based on a region, correct? Like exterior temperatures is over historical average collection of data. And you mentioned about that these programs are going to push more demand onto mechanical systems to create more universal comfort, probably in a home, to balance out the ups and downs. Now, if I factor in this winter where we hit like -15 in the Lower Mainland, which is the first time I've ever experienced that. Alberta issued potential warnings of electrical and grid issues. And then the heat dome, which I was just outside of Boston Bar, which got to 49.9. So I know what that felt
I was right near there.
I actually drove through Linton about an hour before it burnt down that day. So kind of really close to that kind of episode. But my question really comes down to is how well does the STEP code help deal with peak load, as opposed to reducing overall load throughout a home's annual service performance? Is it going to put, I'm just curious to know if the design metrics being put into buildings today may cause another problem into the future, because it's not really recognizing a peak load issue.
Yeah.
That is, and now it's not always good to design based on peak load, because that's not always the most prudent, cost-effective way to go. But I'm just curious to know if that's being thought about with these sort of metrics, and that we may not actually solve the problem about heat domes and extreme cold, because Teddy only deals with annual energy consumption altogether.
So I think the question largely goes as we head down this climate path. Yeah, you want to use less heating, but there is an accompanying code that's now been adopted. The city's had requirements for just direct requirements for emissions, and that's driving the electrification of new and existing buildings. And so I think it gets to this question of the infrastructure needed to get enough electricity to a building, and really. If you look at energy infrastructure, sewage, infrastructure writ large, transportation infrastructure, it's not designed for how many cars go down a road over a year. It's like, we got to get, what's the peak? What's the rush hour? How many cars do we have to get in or out of this particular neighborhood or across this bridge for the peak? And so that has a lot of implications. But to get to your question, Teddy actually really helps minimize peak heating demand. The Teddy requirements are exacerbating. It's making it harder to avoid overheating, which is a little bit counterintuitive. I mean, I'm not a building science expert. We thought, oh, we're adding more insulation, we're lowering the glazing ratio, that should keep heat out. But what we're finding is with the air tightness and the better insulation and the internal heat gains, the people having showers and cooking and, doing yoga or whatever it is they're doing in that building, those internal heat gains, we're trapping the energy. So Teddy alone is going to add more pressure on peak summer loads. The good thing for us is almost all parts of the province, the peak, sort of peak demand where infrastructure is kind of sized to, and this is just a crude, it's, between 4 and 6 p.m. December 23rd. And so we're not really nearing the ultimate peak in many parts of our system on a cooling load basis. So long answer, but Teddy does help mitigate the amount of peak energy required to provide heat for the building.
Anybody else? Sean, one question from me, and whenever I get a regulator in the room, I always like to throw something at them just to throw them off a bit. So the federal government is encouraging provinces to adopt the national code and harmonize. What's Vancouver doing? I mean, as its own entity, charter in Vancouver, will we ever see Vancouver just simply adopting the national code?
Maybe. We're quite a ways off from that. Again, when we began on this work, we used national tools. We used ASHRAE, we used NECB. We just said, oh, you've got to do X% better than ASHRAE. We got to do X%. We were doing a percent better. But what we found was the code structure wasn't getting to the outcomes. But what we find more and more is, though the structure of the federal codes are not quite so performance based and not quite, Teddy is Teddy a metric? I don't know, because I don't follow the national code. If the national codes and therefore the provincial codes, because we look more at harmonizing with the BC looks to harmonize with feds. We look to where we can harmonize with BC. If the national code structure is getting the outcomes we want, yes, it serves everyone interest to kind of align and keep things as simple as possible. But again, we came up with the energy step code is because those code structures, they weren't designed to get the actual outcomes required, and they didn't have the levels of performance. They weren't evolving quick enough. So I think I think you'll see now with the energy step code available province-wide. And now, when we did it, originally we started putting greenhouse gas limits in right away. Now the province just enabled other communities to adopt, it's called the zero carbon step code. It's kind of the mirror of, reduce your energy use and then switch to lower carbon sources of energy. Now other local governments are adopting that as well. So I think you will see probably more and more Vancouver, at least for new construction. Okay, great. We won't create little nuanced differences because generally the outcomes are good. It's consistent. It might not be quite perfect or in how we want to see it done, but we see that harmonization having a benefit. So I can't speak to how BC is going to respond to the feds because I think that a lot depends on federally, politically, where things go and how if they do keep changing or not. But that would be my answer.
Okay, great. All right. Good. Thanks, Sean.
All
Appreciate
right.
it.
Thank you, Terry.
Okay, so we'll just take a minute or two for, we'll get Anton up here and we'll get into the next session.
Okay. Thank you, everybody, for giving me this opportunity to speak. My name's Anton Van Dyke. For those of you that don't know me or haven't seen me before, I have been fairly active in the fenestration industry, more on the residential side, multifamily, wood frame, that type of thing. But a bit of the background towards this topic today and what's inspired me is a bit of where I come from. I like to speak on things that sometimes are, why do we do what we do? And do we just do what we do because we've always done what we've done? And after 25 years in the building science kind of industry, and I started my career out as a building envelope consultant. So I'm going to talk a bit about today about, as a specifier, what did I do to people like you? Because we all read specs and go, what the heck is in this spec? And I can kind of speak on a bit of the concept of what it means to write a specification and how you interpret a spec. I spent about 13 years at Centra Windows dealing with their multifamily sector of the business. So working with architects, building envelope consultants, trying to figure out how to get product compliant with code for more comprehensive projects, and then involved in a lot of commercial at that time too. And now I've recently joined Layton Consulting to kind of dig into more of the engineering consulting world of the fenestration industry, looking at it from an independent perspective, not sort of specific to any type of product. So as the last 5 years has gone on, I've really questioned why the industry does certain things at a certain stage in the industry. The introduction of thermal performance has really put this topic, in my opinion, up front and center about how we choose to calculate this. And if you think EPDs is the next thing, it is. It's project specific. It's not generic. And so this is something that I think is the topic of fenestration engineering. You know, when do we do this? Does anybody want to take a crack about what is the most common time to engineer a fenestration product on a project? After you sign a contract, right? Would everybody agree that that's kind of what's going on? So this is kind of, is the industry set up to be where it's at? And is it going to work the way it's going to work into the future? So just because we've done something the same way forever doesn't mean it's right. So I like to say what's inspired me on this topic. The history, I don't know if you ever get into this stuff on PBS or whatever, but the history of science, you know, when science was invented, Isaac Newton, Einstein, how they came up with these things. So I love this concept of the history of fenestration engineering. You know, why did we decide to start engineering windows? When did we decide? You know, talking to Jonathan and his dad, started out by going to San Francisco after the earthquake and try to determine if buildings could be habitable again after the earthquake in 1989. That's like interesting history that goes into fenestration engineering. How do you figure that out? Who teaches that? Right? So think about that concept. So that's created what I'm going to call the state of play today. That's our current market, is the history of fenestration engineering. The standards we use, do they work for you? Do they help you? Or are they a pain in the butt? Do they not fit within the type of market you're selling your product into? So we need to assess the standards that we're using and whether or not they're actually going to continue to work for us in a new emerging marketplace. And then what can we all do about it? And this is where I really get into the concept of, if you don't like it, let's talk about changing it. So what's the current state of play? An architect draws the concept of a building, creates a rendering, probably then is going to figure out, can I build it? So they're going to talk to a structural engineer who's going to come up with some sort of way of making a skeleton that they can hang this facade off of. Then some consultants are hired, envelope, energy, acoustics. Is the fenestration engineer at this stage at the table? Not too often, right? I wonder why, when the entire envelope in some buildings is fenestration. So we decide who we bring in early. In fact, I spent about 5 years working in Seattle as a building envelope consultant, and I can say the liability stream in the US creates a very interesting dynamic in construction. They have these things called design charrettes. They bring in every professional that's involved in a project around a table in a boardroom for a day, maybe 3 days, and they hash out a design before they even draw a picture. That's something we don't do here, and I don't know why. I think in Europe it's quite popular as well. But the drawings get done. Then we issued for tender drawings, which then we get our pricing, and then we sign contracts, and then we get deals with the bank so we can start to build a building because we got everybody locked in. And only then do we start hiring the fenestration engineer to do glass design, thermal modeling, all the things that we need to do to determine whether or not this glass and aluminum system is going to work well in this building. So this is basically what I call the state of play today. That, we sort of scratch our heads going, what is the right methodology to apply this logic? And the skill set exists everywhere. Could we consider something like this happening at this sort of stage? Now, to look at what we do as beneficial, like why has it worked well? Why do we do what we do? Because it has worked. It has given us some sort of framework of structure. And most people will come at it as every manufacturer has its own unique design, its own unique system. Therefore, how can an architect design something proactively, generically, early on in the stage of a project? So it's a very common specification requirement to say to the fenestration supplier, manufacturer, installer, to provide engineered shop drawings with your product. That's just become the nature of the industry. And it's worked very, very well based on systems that I would call very standardized. So then we look at NFRC and NAFS. I'm going to say these are the two most common standards we use in our industry that are going to dictate thermal, structural, air leakage, water. We'd probably throw a new one in there called EPDs as a new design metric that we're all going to have to start paying attention to. These standards all come with things called gateway size testing. Well, why is that? Well, gateway size testing was done specifically so people could shop around. They weren't done for design numbers. They weren't designed to give to an energy advisor to say, design my building with this U value, because it's based on a certain size product. And so we're running into issues using gateway size testing of products to design product early, because it's not an accurate representation of the actual product that we're going to do. So it forces us into this post-designed engineering system. So it may have worked well when we had standardized sizing more commonly, but it may not work as well today. The number 3 thing that I think drives most of it is the competitiveness. Developers and contractors love the fact that they can lump everybody into one pool, competitively bid on a project, and then figure out some of the structural design after. It may not be the best approach, but it's something to understand and reflect a bit on. So the standards we have, most of you will understand this, NFRC and NAFS, and I pull these two out because I think they do the best job at explaining kind of the thermal, structural, air, and water tightness aspects of what we're always trying to accomplish within the envelope for its integrity, its performance, and what we're trying to design and bring engineering into the fold. And like I said, they use this standardized size. This is for the NFRC gateway size. How many of you would say that you're selling product that is at this size on a daily basis? Not a single hand goes up in the room, yet NFRC says that's a standard size for curtain wall. What? Why? And I actually I do a lot of back and forth on LinkedIn with people, and I got into an interesting conversation with a fenestration consultant out of Florida who was basically saying, our NFRC gateway sizes, our standard sizes, are they obsolete? Do they make sense? Are they too small? Are they too big? Should we reevaluate them for what they are? And so I think these are really, really good questions. I think the answer is yes, by the way. Now, is there a will to do something about it? Yeah, Jason's shaking his head, no. So I think it's a matter of reflecting on, like, why do we have these standards? And these standards only were written at a time. This is where I like to go back to the history. Does anybody know when NFRC was created? What date? Terry, you got to know this. Mid-80s? NAFS. I think the original NAFS standards in the US might go back to the 50s or 60s. Was our construction industry different back then than it is today? So have the standards changed much from then to today? A little bit. But the gateway sizes are the same. So I pulled 4 buildings in Vancouver. The Marine building in City Hall. It actually looks like somebody bought the windows from the same store for both buildings. So these standards were written You think about it, at a time when a lot of window companies made punched openings the same size in mass quantities, put them on a shelf, and they told architects what size windows they sold. Nowadays, what happens when an architect calls you? How big of a window can you make? And you tell them how big of a window you can make. Doesn't mean it'll work well, but if it fits on the back of a truck and it can be hoisted up by a crane and put in by people, that's as big as it can be. It doesn't necessarily mean it's the same. So our standards are coming from an era of this, and we're trying to apply them to an era of this. Very, very different landscape and state of play that we're actually into. So what I'm going to be talking about today is not have a lot of answers for you, but what I'm actually going to bring forward is the processes we're using for fenestration engineering may not be the right approach that we've been using because they're based on an era of this. So this is, I believe, the Carina and the Callisto and the Ericsson building, which have curved glazing and very, very unique systems, and none of them come close to matching the standards that we use in fenestration. So it forces us into something different. And you'd actually be amazed. There's a website, if you just Google it, it's reality versus outcome rendering, architectural rendering versus outcome. And this is, I think, what we try to do as engineers, fenestration engineers. I'm not an engineer, by the way, but our company is full of them, is we try to make architectural dreams come true. Now, how do you make an architectural dream come true when you're asked to engineer the fenestration after the fenestration contractor has signed a contract with the general contractor? It's very, very, very difficult to do. So we look at these concepts. Oop, I'm gonna go too fast here. We look at these concepts and we can actually help design some of these things early on. And the other little meme here I like to throw in is the concept of siloing design. And if I take a bit of the earlier conversation about accessibility that we talked about, this is an area of concern I have when it comes to the building code, is when we start adding accessibility into fenestration, especially doors, people that are so focused on accessibility, they might be one consultant in here. So we say to somebody saying, design a door to accessibility. What are you going to get? You're going to get a door that's very leaky, probably. Now, if you go to an envelope consultant and say, design a door that's very air and watertight, you're going to get a door that's not very accessible. And so we're going to run into this situation very, very commonly when you give design professionals their own metric and we don't actually put them in a room together to sit around the table and design something or come up with something that's universal that's going to work. So our goal at the end of the day is for the desired outcome to be fulfilled in a building, and how we choose to apply fenestration engineering and at what stage is going to dictate how we get there. So the real inspiration that I have for this whole topic, and I'm going to tell a bit of a story here, it goes back about a year and a half ago, is I was bidding on a project. We were given the issued for tender documents. This would have been a 6-story wood frame building with windows. The specification was just simple, all windows to have a U value of 1.4. I think it referenced NFRC 100 and 200 for solar heat gain. So I wasn't under any impression that there was any other expectation than to provide a product that met an NFRC U value of 1.4, which I did. I had designed a product that was at 1.39, which I knew if anything changed in that product, it would not meet 1.4. So I knew I was right at the cusp of getting it in there. I could have quoted a higher performance product just to be safe, but I didn't because I wanted the lowest price. So I win the project, we get the contract, we sign all the contracts based on meeting this requirement and having the lowest bid. So we start the shop drawing stage, right? After we sign contracts, of course, that's the standard process. And we put together the shop drawings, and the shop drawings, we reference the U value of 1.4. We go through all the preliminary structural designs, get all the NAFs, air, water leakage, and everything sorted out. And we send it off to our client, who sends it to the architect, to the envelope consultant, to the energy advisor. Lo and behold, the drawings come back, and it says, the energy advisor is requiring an overall project size and configuration U value of 1.4. Like, wait a second. I provided U values based on NFRC standard sizes. Now they want U values based on specific project size and configurations with mullions and everything that comes into it. And I knew I was at 1.39 going, this is going to put me over. Now what do I do? And the reality is, I had a contract that basically said that 1.4 was the requirement. It referenced the issued for tender documents. And I knew, so I put my foot down and I said, no, I'm not doing that. And this sort of triggered a whole new conversation that people weren't quite ready to have, was what is actually required for this project? Why did we go from NFRC standard sizes to now it has to be project specific? And how come nobody was told about this until after contracts were signed and everything was worked out? So because I refused to just do it and provide a higher performance product, which in this case would have meant going to triple glazing, but because I had a contract signed, there was an expectation that I was going to be doing this free of charge, because they were saying the project required a project-specific U value of 1.4. And the architect pulled up the specs, which it said it, and I was really confused, only to my amusement that they were sharing with me the issued for construction documents, which were different than the issued for tender documents. So there was a revision that happened at some point where they didn't tell anybody. So at the end of the day, I got out of it because I had a contract that referenced these documents, not the issued for construction documents. That is a great, great, great situation. So I'm in a position now where I had a really good contract lawyer who taught me the formal contract process really, really well. So he said, request a site instruction, an SI, which basically said, which was going to revise my contract, which triggered a change order. And so it basically triggered about $150,000 cost increase on a project to go from double to triple glazing, which ended up putting the project over budget, which the whole thing stopped. And to this day, they canceled their contract and I have no idea what they did. That's how much of a debacle this actual issue is. And this is this is one of many, many, many examples. And I hate to say it, but talking to some of my colleagues and some of my competition out there, the number of companies that would just go, oh, I guess I got to provide triple glazing free of charge. They just do it. And then this creates this behavior and it repeats and it goes on and on and on and on. And so the issue really comes down to is why the heck are we doing design work after we sign contracts? That's really what it boils down to. And so to me, this is where I look at the existing state of play. And I used to use this line. I used to manage a team of sales reps, and I always called it kicking the can, because sales reps are the best at kicking the can down the road for someone else to figure it out. And I like to say architects that specify, or any specifier that specifies that the fenestration manufacturer is to do all of its own engineering and does not incorporate any of it up front, is like kicking the can down the road. And what happens when we keep kicking the can down the road? We get a nice big high rise of cans. And so just trying to create this sort of concept that we don't have to necessarily kick this can down the road if we choose to do something a little bit differently. And it's just opening our eyes up to a potential different process that we can follow, and we don't have to do it. So I would strongly recommend that anybody that is operating in an industry where you're asked to do post-contract engineering and design, that you understand your contractual obligation extremely well, and you know how to formally manage that contract. Because when you're dealing with large developers, actually, this is something that I've learned, the bigger the developer, the better they are at using contracts formally in their process. And so when you can match their process with your process, and basically, and this is what a lawyer taught me, is the minute there's a deviation from your spec, just ask for a site instruction. It forces the general contractor to recognize that something was changed. And the minute they recognize something wasn't changed, you're entitled to a change order, and away you go. Now, you don't always make friends this way, but when you follow the formal process, you earn a lot of respect. And that's just something I recommend. So what was that? You get a new boat? So well put. I do want to say, we hear everybody talk about specifications, the frustration with copy and paste specifications, right? Everyone's seen this, it goes on and on. Are you aware that specifications are held higher in priority than drawings? Does that create some sort of potential opportunity? Because I would say more often drawings are the more accurate document when you're bidding on projects than specifications are, yet specifications trump drawings. So understanding that process actually can help you out significantly when you dig into this sort of aspect. None of this is an issue, or none of this was an issue until we got into very specific project design metrics. And as we bring in thermal, and you're going to see it as you start to bring in EPDs, EPDs are going to trigger another thing, because EPDs isn't just the documentation on your product. It's the documentation on your product based on its glass to frame ratio, based on all of its components that are made up, which now become project specific aspects into your design. So how do we get in front of this? This is kind of, so I identified the problem. It could work. We could continue to maintain the same system that we have. We can continue to react to these situations. We can continue to create conflict by basically saying, hey, I'm not going to do that at a time when you're probably going to trigger delays in contracts, which is another problem. So that's another issue with doing a lot of this design work after the fact as opposed to proactively, is construction delays are the biggest cost issue that you're always going to run into. So we're trying to avoid conflict during times when you just don't have time to hash it out. And that's why people end up either getting pressured into doing things that may not be beneficial. The comment I have heard, especially in the commercial side, is frustration around every architect bases its spec based on one manufacturer as the basis of design, and I have to figure out how to align my product with their basis of design. So it's a frustrating sort of comment that everybody will make. And I call, in a roundabout way, when you look at specs and it says pre-approved product and there's one manufacturer listed, and then it says or approved alternate, that or approved alternate process at the time of tender, is there usually enough time to get approved? What's that? Negative, right? So it's a bit of a trap. And so the idea here is, how do we set ourselves up, all of us up as a collective group, where you create this basis of design concept to really make it easier for a specifier to specify commercial glazing, fenestration, in a way that is universal for everybody. So it opens the door for everybody. It's also recognizing the fact that architects need to know a little about a lot. Any architects in the room? Yeah. So just knowing a little about a lot. You can't be an expert of every single person's product. So how does a manufacturer stand out? How does a manufacturer demonstrate to an architect its product's performance early enough so it can be designed into a project early and go about it? So it's respecting that aspect of an architect. If you don't respect that part of architecture, you're going to have a very, very tough time in this world. In my 20s, when I was acting as a building envelope consultant, I was dating an architect. So she taught me a lot of lessons about how architects work. And so I'll never forget that, because it's just life lessons you bring into what you do, and it works out. So plus I used to write specs, and I took a course on spec writing. So you kind of start to understand a bit the nature of this. But how do we create generic basis of designs? Like, we have wood frame manuals, we have reinforced concrete manuals, we have structural steel manuals that designers can use in a generic sense to design a building. But in fenestration, we're kind of stuck with every manufacturer has its own profile, which has its own deflection and loads and calculations that go with it. But glass is still glass, so glass could be generic. So it's recognizing that we don't have to be stuck in this customized world all the time. That is there a way we can actually start to pull out information to create some generic design metrics that we can do? And this is something that we do all the time, where we can kind of look at cross sections and come up with conceptual design aspects that go into a project. So this is sort of the idea of starting to look at something different and a different process for how we go about it. So I'm going to go back to the standards, NFRC and NAFS. And when I use these two standards, I'm referring, like I said, to thermal, structural, air, and water, the four main kind of metrics that we're always sort of stuck engineering or finding solutions for. And it's recognizing now that this is the standard size for curtain wall in NFRC, which is 2 meters by 2 meters, and it's considered a fixed window with a vertical mullion down the middle. NAFS doesn't even reference curtain wall or storefront. It's not actually part of the program. So, but that doesn't mean your product has to meet air, water, and structural requirements. So in theory, NAFS does apply to your product. It's just outside of the standard. So I kind of use NAFS as a good example. Even though you don't have to be NAFS compliant, you still have to meet the requirements of NAFS. And so looking at these sizes, we ask ourselves, what could I do different with this size here that starts to create some design data that a designer could use for their project? Does it make sense to design a product around 2 meters by 2 meters when I don't make anything that's 2 meters by 2 meters? What's the point in having that information if it can't be used by a designer to design a building? And so if we look at a couple different types of commercial buildings, NFRC has nothing really it can do with the wall center. And then an Apple store, these are very common kind of commercial settings where the data you're going to get by getting an NFRC number is kind of useless. And so we're starting to ask, have we moved beyond standards for when it comes to doing performance evaluations of specific buildings? And so let's spend a bit of time on this one. So what could you do for your product to give design data? So if NFRC is saying 2 meters by 2 meters with a mullion in the middle, so that's basically a mullion spaced at 1 meter on center, and the building you're supplying your product to has a mullion at 1.5 meters on center, is there potentially data you could proactively have that would show what your U value would be if you were at, 8 inches on center, 12 inches, 24, 36, 48, and start going from there and looking at what is your glass to frame ratio and what's that information over, let's take a 10 by 10, 100 square foot area of curtain wall. Could a designer designing a building use that information to determine what spacing of mullions is ideal for the output? So Sean had that Pathfinder thing up there, and it had those U values. Is Sean still here? I don't know if he's left. I don't know if those U values are NFRC standard size U values or if those are project specific U values, because if those are project specific U values, how does an architect know that the product they've specified can achieve that U value that they've listed on that Pathfinder if it's project specific? They don't. No one will find out until they've signed a contract and done the project specific thermal modeling. And I'm going to show an example of when that how that can all fall apart if you don't plan for it properly. So the question is, how can you use this process of NFRC to create data that a designer could use different than someone comparing your product from another manufacturer? And this is where the creative mind comes into play. There's no set, here's what to do. No one's going to tell you what to do. It's a matter of knowing how a designer is inputting your data into their system first, and then developing data that they can use for that input. So I like this quote. A mentor of mine taught me this many years ago. If you don't like the way something is, get involved and change it. This is the reality of what we do, why we do what we do. I don't like this system. I think this system is unfair. And I think we need to consider different ways of doing it. So an idea is to look at, okay, option one, what if you created your own sizes instead of using NFRC sizes that better represented the product you're selling? That could be a very simple thing to do. In fact, I'm working with a bifold door manufacturer that makes about 8 different stock sizes that are way outside of NFRC. And I'm like, well, why don't we get a U value for all 8 of your sizes? Done. How valuable is that information to an energy advisor designing a 16 by 8 foot bifold door on a single family home? And those are the kind of things that you can create that information. This will unfortunately have a higher cost because you got to do a lot of proactive evaluations. But that information then can be used by a designer as a basis of design into your project. And the idea here is to invest more into upfront information as opposed to having to do all of this after you sign a contract and have been awarded a project. These tools also help your estimating teams out with determining whether or not you can meet that design metric as you're pricing a project out, or whether or not you need to upgrade to a certain low E or glass or different thermal break system in your assembly. The other option, now it's something I think that needs to be done, but I don't think it's going to happen too quickly, is to create an industry, is to update the industry. Let's sit down with NFRC and talk about their sizes first. Do they need to be bigger? Maybe we need 3 sizes. For example, NAFS has different classes, R, LC, CW, AW, and they all have different gateway sizes. So maybe that's something we can do. But it's going to take a long time. And if I use the combustible window change requirement that's popped up in the national code, Terry, that's been what, a decade? Started at 2004-ish, 2005. And we just finally have seen this come into the code. So any changes in this realm, expect a minimum of 10 years before you see any outcome come. And then it's got to be codified, which will probably add another 5 years. So, but they actually create the same outcome in a roundabout way. So just putting forward ideas, and I think industry has the first opportunity to take the bull by the horns and basically say, what can we prepare for our product that gives designers and energy advisors the data they need to input into their systems, like Pathfinder that Sean showed, HOT 2000, NECB, ASHRAE 90.1. What do they need and what can I provide and give them? Passive house. I don't like to be a proponent of passive house because I think there's many other ways to get high performance. But passive house has developed a very good process on how to manage project-specific thermal modeling. And I think it's worth studying a little bit to kind of go, here's something that works, but it works with buy-in from an entire team of designers harmonizing together and putting everything into one sort of bucket. And the first part is Passive House requires a manufacturer. So I'm using the Passive House US certificate because I think it just does a really good job at summarizing thermal performance for windows on one page. So we're used to in North America getting whole window U values, right? Under NFRC's solar heat gain. Passive House does whole window values, but it also breaks it down into frame value, the edge of glass value or spacer, and the center of glass. And what that allows a designer to do is take project-specific configurations and input them into the system, which will spit out a project-specific thermal outcome. So they've actually recognized the fact that we need to be more specific with our data. And so any thermal meeting we've been in probably the last couple of years with FenCan talking about how to deal with the City of Vancouver's energy modeling guideline, the NECB, the ones that are looking for more accurate data, everybody keeps kind of going, well, couldn't we get thermal modeling reports that break things down into these values? In fact, I think a lot do. And I'm going to go back to Intertek and some of my experiences working with Intertek getting thermal modeling. If you go to like the 10th page, which is like this data page, if you know how to read it, you can start to pick out the data. It's in there, or at least it used to be. But the thermal modelers have this information. And so with this information, because we know how to deal with it, with the certain software, we can create this project-specific outcome. However, it takes significant commitment from an owner, developer, early on in a project, because what is a passive house project? It has two things that non-passive house projects typically have. It has software, the passive house planning package, which is basically how they do the project-specific calculation. And it has a dedicated consultant hired at an early stage of a project. And so what happens when you bid on a passive house project is you're going to bid on a passive house project with this information at the same time. So it's not price specific. It's going to be price specific based on your ability to hit the target. So before you sign a contract, you're going to do this calculation, determine you hit the design criteria, then you're deemed to be compliant with the project. And that's kind of how passive house has decided to work. And so what we're trying to do with project-specific thermal modeling in our industry is in a roundabout way what passive house is promoting, but without the team of professionals involved in the project to help manage that system and make it work. So I think we have to be careful when we say, well, it worked here, but yeah, it worked there because of how everybody got together. I'm going to pivot a little bit off of thermal, and I want to talk about air, water, and structural, otherwise NAFs. If I was talking to a bunch of residential window people, I'd be saying NAFs, air, water, and structural. And the reason why I kind of bring in the NAFs concept of understanding here is we're all aware that the NAF standard, it not intended to be tested to the standard. You have curtain wall and storefront. And so I'll work with a few commercial glazing contractors and manufacturers who will say, well, we don't have to be NAFs compliant. We fall outside of the standard. However, how many of you have to meet air, water, and structural requirements for your project? Everybody? So we have to. So can we actually use the NAF standard to demonstrate our product's ability and performance? And the answer is yes. So it's just using the standard in a different way that we would not normally use it. And so if I actually break down the code, and I got the national code here, so we can either use NAFs or we can use part 5 of the code. And for those of you that aren't aware of this subtle change in the national code, is it went from a very simple use NAFs or these 3 sections in part 5 Now it basically says if the products are not covered in NAFs, you can only use these 3 sections, which in theory would cover all commercial glazing systems. So whether you're in NAFs or not, you're obligated by code to meet structural, that's 5141, air is 54, and 56 is your water tightness. So you still have to meet this criteria. So if you came to me as a specifier and said, hey, I got this really cool product, I'd like you to specify it on my project. I was an envelope consultant when I was a specifier, so what's my response going to be? What's its water tightness? Well, we don't have to test it because it's not part of NAPS, would be a response. Okay, but I still have to prove that it meets that. So as a specifier, I need something. I need data. I can't just get oh, it's good. It's a really good product. Oh, I don't have to meet that standard. Doesn't matter. There's risk. In BC, if the leaks, we had leaky condos. So there's a whole reason why we have envelope consultants. So how do you demonstrate that the product is going to meet 5.6? Now, with the step code, we have air tightness. How do you demonstrate that it's airtight? Structure is pretty easy because that's kind of a very known structural design aspect of what we do. And this is where I discovered way back in 2012, 2013, 2014, when NAFs kind of got introduced into the BC building code, we had meeting after meeting after meeting. And from 2012 to 2013, then there was the delay. 2014, there was a code committee to kind of revise this whole system. But I started looking at how NAFs was written and said, is there a way I can apply NAFs to demonstrate to architects, specifiers, how our product would perform going into multifamily complex projects that kind of NAFs didn't really seem to address all that well. And so when you look at the NAF standard, it's going to tell you your gateway sizes for testing based on the product configuration. And some people would say, well, I just have to test to the gateway size and we're done. What kind of information does that give a specifier in order to get pre-approved into the design? Very, very little, because you're kind of looking at individual units like this. Versus what if I built a large product and as big as a product as I could put in a booth and test it, what information would that give me, and go from there. And so you can kind of look at using a standard. So yes, there's no curtain wall referenced in NAFs, but I'm going to say, I'm going to take a fixed window. And ironically, there's a note in here that even excludes curtain wall and storefront from this standard, but I'm still going to use it as a universal standard approach to demonstrate how well a product can perform, because you can't argue with the standard. So you're still using a standard. And studying this part of the NAFs where you said, well, this product qualifies this product and this product qualifies that product, I actually built a window that looks like this. Only a mother could love a window like that. No one's ever going to buy it. But the idea is how big of a window can I put in a booth of all different configurations that I could put in that if I sat across the table from an architect or a building envelope consultant that said, prove to me your window will meet 510 pascals, and I showed them a test report for a window like this, it's done. There was no doubt about what the product could or couldn't do. And so it wasn't about doing testing for compliance, for code minimum. It was about doing testing to demonstrate to a designer who is concerned about a certain metric. So if it was an envelope consultant, it was water. Today, if it's an energy advisor, it's air. If it's an architect, it might be structural. And so it's important to grasp those concepts. And I'm going to talk about the combustibility thing in a bit, but you've seen a lot of vinyl and fiberglass window companies wanting to go into the high-rise market because of the code change. Well, how are you demonstrating you can meet it structurally? That becomes another conversation. So I'm going to give Jonathan Layton the credit for these few slides coming up. But here's a real life example of a situation where thermal modeling was done post-contract. So it's a 10-story building, and the specification was for 1.22. Don't know why 1.22, whether it was a step code requirement, whatever's driving that specification criteria. The system then, we modeled the system based on its current glass to frame ratio, and the outcome was 1.354. So it's not meeting the specification. It's not meeting the energy advisor's requirement for energy efficiency that's going to go into it. So now what? What do you do? Anybody got a recommendation? So the problem with this is the product under NFRC standard size thermal modeling, which is a window configuration like this for curtain wall, its U value came out at, what does that say? 1.01. So really good. It's triple glazed, aluminum, thermally broken. Seems like an advanced curtain wall product. That would be really good. But it's based on a frame to glass ratio of this. So what happens when we start looking at the building that has a frame to glass ratio of that? And we have these horizontal mullions that come through. The NFRC standard size is not accounting for that. So how do we make the decision early on to know the impact that this specific architectural mullion layout, what impact is that going to have on our product? And so just playing around, being a little bit, not a friend to an architect, we decided to just, what if we delete this horizontal mullion to reduce that thermal bridging to give us a bit more of a metric that'll work. And we end up at a 1.275 by making that slight change. Now, architecturally, is that fun to do? Can you even do that after development permits are done, the aesthetics are all figured out? Can you just remove a mullion? Now, this product is already maxed out at triple glazing. So there's not much more you can do to the window to increase its value. Maybe if I go, here, I'll go down. You can see here the casement windows is kind of penalizing this at 1.9. So is there something to do with the casement windows? The point I'm trying to make out here is this is a design issue. This isn't something you can figure out at the shop drawing stage after you've signed contracts. You're going to get delays in the project. Everyone's going to have to go to meetings. And if you signed a contract based on hitting 1.2 and now you're not, what does that mean? Someone's going to have to make a decision. Who? Now, does anybody know the difference between 1.22 and 1. What did I have? Was the 1.354? Anybody want to know how big of a spread that is in R value? 0.52. I just did the math. So as a designer, is there an energy advisor in the room? Would that make a difference? 0.5 R value to the Teddy calculation? I don't know. But that's a decision that's going to have to be made, is someone is going to have to decide to accept something like this, or decide to remove a mullion, or decide to accept a lower R value. Who's that person? And the point I'm trying to get at is if we did this calculation early on, that decision would have been made way earlier at the schematic design drawing stage of a project. And so we're trying to get the message out more and more to architects, to developers, that fenestration engineering, whether it's done early or after, doesn't matter. The cost is the cost. The service is the service. But how much aggravation will you save if you bring it forward into a project? A bit of an example of how things can be done well. I got till 3, right? So this is an example of a building in Dusseldorf, Germany. I don't know, I'm not privy to exactly what it is, but the studies of the engineering on this from a structural perspective, this is one big giant atrium with spider glazing, where the story behind this is the early design of architecture, structural design, and the fenestration engineering was all done early on in a project, which enables a building like this all to happen efficiently and effectively going into the design work. So there are ways of doing it. And if you look at some methodologies used in the US, in Europe, there's a lot of early fenestration design going on. And just trying to get the message out there that we can help out as early as possible. I'm probably going to be done here in the next little bit, so we'll have a lot of time for questions. So what can we do to change the state of play? And so this is really what I'm hoping to get out of today's conversation with everybody is there's an opportunity for everybody to play a role in doing something a little bit different, which might create a new opportunity and a new outcome for our industry. And so from a manufacturer's perspective, it's looking at the current, what is your basis of design? Do you have a manual? Do you have design metrics that you could give to an energy advisor or an architect to develop product or to select the right product for their design that's going into it? And for commercial glazing contractors, this code change, if you're in the aluminum business and the aluminum business is what keeps my certain market going, this code change is something to pay close attention to. So this is the 2018 BCBC versus the 2024 for combustibility of windows, where basically the old code said combustible windows were only permitted in non-combustible construction if it met this criteria. And now combustible windows are permitted in non-combustible construction. Done. That's it. So what does this mean for punched openings going into a 25-story building? Does it have to be aluminum? If a vinyl or fiberglass window manufacturer can demonstrate that they meet the deflection, the structural, and everything, that market's free for them. And I've talked to a lot of these window manufacturers they're going, what do I need to know in order to get into this market? And it's like, test. Like, can you prove that you can meet PG 55? Because that's going to be what you need for structural for a 25-story building. Can you prove you can meet L over 175 deflection at a 10-foot mullion span? Yes or no? Well, I haven't done the testing. Okay, the answer is no. So there's a group of people trying to figure out what do they need to do to demonstrate that their product can meet the structural requirements of these types of projects early on. And this is the messaging that I've been trying to get out is the more you develop up front for your design metric tools, it becomes a business development strategy, it becomes a sales strategy, it becomes every aspect that goes into your business to pre-engineer these systems so you're not trying to figure it out after the fact. And you're basically just creating confidence to the specifying world that your product can do what you say it can do through testing. Designers, reality is engage with the fenestration engineer early in the design stage. I'm not trying to change how much work we do. I'm just trying to change when we do it. And that's it. And the more we can do early on, the easier it's going to be for you and the better it's going to be for the architect to get what they want at the end of the day. And most importantly, and this is something that I don't think is being done enough, is the coordinating registered professional, which a lot of cases is the architect, is how involved are you at the tender stage? How involved are you at accepting or determining whether or not that price represents the product that you specified? I don't think a lot of architects are engaged at that stage. And the reason why I bring that up is when I did envelope consulting, I remember on the roofing side, we would specify a certain type of roof. And then we'd have a site meeting with the roofer who was the low bid to go over what they're going to do, only to find out the roofer just bid on whatever the heck they wanted to bid. And the contractor awarded them the contract. And I said, well, that wasn't my design. And you'd get overruled by the developer. And basically because it was the lowest price. And so now if that was a deal breaker, and as a professional, I said, no, I'm not going to accept that. And I wouldn't provide letters of assurance. That becomes a problem. And so I think an important step here is to ask for critical elements like a facade that has an architectural, a structural, an envelope, and a price component to it. Are we engaging the right team to make the decision at a stage that's healthy for the actual project to be successful? So basically, in summary, I figured I got about 15 years left of energy to slowly chip away at changing the state of play of our industry. Coming from a world of expanding products into multifamily and the evolution of codes, I would say that probably EPDs, everyone seems to be kind of worried about this thing. What is an EPD? It's just the fear of the unknown. The reality is we've been studying the concept of EPDs for fenestration and what it's going to take to put these documents together for companies like yourself. And EPDs is going to fall into the same category as project-specific thermal modeling from the best we can tell. Because it's not like you can get a glass EPD, you can get an aluminum EPD, but as a glazing contractor, you're going to have to submit the data based on the glass to frame ratio, which is going to be unique to every single building. Now, what happens under the Vancouver Code 10.4, they don't specify that fenestration needs an EPD. They specify how much carbon a building can consume. That's it. So now it's up to a professional to determine how much your product contributes to that overall calculation. If they double the aluminum to glass ratio, does it throw it out of whack? If they reduce it, how do we make these decisions early on? And so it's going to start to play out a little bit. To me, I think there's an appetite for bringing fenestration engineering in early. Why? Because we bring our acoustic consultant, our envelope consultant, our energy advisor. we all hire them early on in the design stage. Acoustics is a really good example where they'll specify prescriptive acoustic requirements typically based on one manufacturer's data, and everyone else has to account for it. So it's not overly difficult to do. Coordinate structural and architectural designs with fenestration design early, like I talked about. The basis of design manuals, just try to come up with a name. To me, the world of design today, going like if I go back 20 years ago, did we have U values specified 20 years ago? Yeah. So commercial, you probably had to meet a certain metric to meet ASHRAE 90.1, but it was what, 2.67, 2.7, sometimes 3.0. Now, what are you seeing in specs for commercial high-rise buildings? Like the one I just showed, they were specing 1.2. Like what's a typical commercial high-rise U-value spec that you see? Anybody? 1.6, 1.7. If you had a product that's just meeting 1.6 and the codes change to 1.2, what do? Right? So you have to start looking at where these codes are going and the basis of design manuals. The cool part about this is as you go to project specific, your glass to frame ratio can sometimes get a lot bigger, which means you can get a better outcome. So sticking with NFRC data may not always give you the best performance data. And so using NFRC to demonstrate overall performance can be a big one. And I bold this one, pre-engineering design concepts outside of standards. And that's really is, can you create these tools that a designer can use? And what I like to do is sit down with energy advisors, find out what do you want? Then I sit down with a manufacturer and I say, what can you provide? And I go, are they the same? And it's almost sometimes like I'll act as a therapist between designer and manufacturer to say, if you can bring both of these together, we got a perfect world. And you'll find really quickly those that are operating within NFRC standards or NAF standards or these sort of set rule books are going to find themselves falling behind because the code is going all project specific. That's really, everything is going performance based. There's very, very, very little in the code that's prescriptive. In fact, the prescriptive requirements in the BCBC of 1.22, I asked Junie what markets would actually use this because step 3 is minimum. And they go, jurisdictions that have no energy advisors. That's what it's for. Like up northern BC where there isn't an energy advisor and you can't physically use step 3. That's the only reason for prescriptive requirements in the building code. And so prescriptive to me is like using NFRC for its full value. Can you put an NFRC label on a product that exceeds, or okay, let me rephrase that. What does it mean to put an NFRC label on a product bigger than the NFRC standard size? Or smaller? Is the label reflective of the product? No. Yeah. But how many people realize that the data on an NFRC label doesn't represent the actual product they're looking at? I bet you 20%, most don't realize that. And so when you get into the commercial world, everything is outside of NFRC limits, yet we're getting everything certified to NFRC. So, but what I'm saying is there's ways we can use it to help create tools to help everybody here. So, and number one, it's a team. I can't help but say this more. The more we try to silo design things, the more you're going to separate everything. It's a team of people. You have to engage with the energy advisor, your fenestration engineer, your manufacturer, everybody all at once to sort of come up with the overall concept. So, and that's it.
Questions? It's got to be some questions for Anton. We've got a bit of time. So Anton, you talked about site-specific thermal numbers, but I didn't hear you get into the driver that's causing that. So my friend here from Layton, Mr. Jomo, you're going to tell us about the EMG and why we ended up where we are today.
Sounds good. So yeah, full of acronyms in this industry. Yeah, the City of Vancouver Energy Modeling Guideline. That's what essentially initiated your surprise job. Was released, I don't know, two years ago or 3 years ago, but it just landed, and it essentially, the wording was, we do not want the labeled values. It must be site specific, and that was it. And then the next paragraph was something copy and pasted right from the CSA NFRC standard. And so all of a sudden, the industry just got basically told, I don't care if you certify stuff, we don't want it. And whereas certification one time was the qualifier or to be able to purchase between two suppliers or multiple suppliers, and all of a sudden it was just like, well, dump that, give us site specific. And that, I think, in the way that it came out and then the way that it was applied by the parties that were involved at the design stage, basically just said, too bad. And we were involved with clients who had, $600,000, $700,000, $800,000 window packages already built. Like, how bad do you want an $800,000 window package? Already built that, according to this new wording, wouldn't comply. So it just caught right off guard. And so I get the initiation of it was, well, we want to be able to quantify how much the impact of the window is making on the specific building. But they did it in such a way that was like, too bad you've been doing that thing. Thanks for buying into that. You're out now. And yeah, go ahead, Anton.
Well, so the whole debate comes down to accuracy at the end of the day. And one of the reasons why I asked Sean Pander that question about the Teddy versus peak demand is I've learned everything in thermal is based on a set of not necessarily fictitious, but someone's determined environmental boundary conditions. So it's not actually representative of the specific performance of an entire seasonal up and down kind of condition. It's representing a few things. And it's kind of like the automotive industry. When you buy a car, you got a sticker on the window that says, whatever, 15 liters per 100 kilometers. That's based on very, very set conditions, altitude, how fast it's going. So there's a standard, I'm assuming, behind that so that every car manufacturer tests their product to the same parameters. So when you're shopping, you can compare, oh, this one's 10 liters, that one's 15 liters, this one's 20. I want to buy that one. And you can make that decision as a buyer. But then you drive the car and you go, what the heck? It consumed way more gas than advertised. Do you go back to the dealership and say, hey, that's false advertising? No, they're going to cite that was based on blah, 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 blah. That's NFRC. So NFRC does not represent how your product will perform in its actual situation. And so the government knows this. So the government's changed this without really telling anybody that this is a new thing. And I put on the residential side, when this first popped up, I said, heck no, I'm not doing this, because I knew the risk of bringing in mullions and all of these things into it. Number one, the liability, because it wasn't like they were saying you need to hire a third party. They said, I had to do it. And I go, but I'm not even trained to do it. And they said, just give me a number. I'm like, but I'm not gonna, a number on what?
A number that works.
And I'm like, so what if it doesn't perform? Am I liable? And then we started having meetings with the government about this new thing that came in. And number one, it's called the City of Vancouver's Energy Modeling Guideline, and it's referenced in the BC, by the way. So my first opposition was this building was in Victoria. I don't have to follow that. Yeah. But at the end of the day, I said, our contract doesn't allow for this. And the government policy writers go, I don't understand. They didn't understand construction contract law. And to me, that was the biggest red flag, was that the policy being written in the code is then being specified by architects to kind of what I call kick the can, because they're going, I don't know how to deal with this. How do I do this proactively? I don't. I'm just going to get the manufacturer to do it later on. But after they sign a contract, and I think the issue that I'm having with this, coming from my personal life experience, is it's forcing manufacturers to make commitments to contractual commitments that they're not aware of. Yeah. And that's scary, because you're going to have a project where you bid on it with double glazing, and you're going to find out after the fact that it has to be triple. And who's going to pay for that? And if it says in the spec, U-values to be project specific, you are paying for that. Is based on my conversations that I've had with some really big developers who have zero. They just don't care. If it's in the spec and it's in your contract, you have to do it.
What are some examples, like how can you work with an energy specific model before quoting?
Yeah. So curtain wall to me would be the first one to go after, because you basically can just come, let's say you came up with a frame to glass ratio, let's take 75%, 80, like just go in 5% increments, and you created a U value for 80%, 85, 90, 95% based on your frame to glass ratio. based on, let's take a 100 square foot area. Now, if I'm a designer designing a building that's 20 stories tall, I could take that data and go, oh, if I go 48 inches on center, my U value is going to come in at around this. If I go 36 inches on center, it'll be that. If I add another horizontal, it'll be this. That's generic information that every manufacturer could produce that would give a designer the ability to make a decision early on. That's, to me, just a little bit extra work, like you did your NFRC data, but then 8 other modeled size configurations with different mullions.
And if I can plug what we've been doing on the Fen Canada side, so we've been, there is math that exists. NFRC's approved the math where we can use the certified product directory values, so your certified values. And because CSA and NFRC are aligned, we can do the same. But we, along with the task group of Fen Canada, helping rewrite the City of Vancouver Energy Modeling Guideline to say, hey, there's value in having your product certified. We can actually use those values to back calculate your frame and your IGU. I can use those to actually create a linear calculation based on, you could switch out your glass and you'll know what your different values are. It's, you know, an effort to, I guess to the manufacturer is your product current? Is it certified? Is it like, if you want the data in order to, like you said, use that data to provide for you what we need. And that's really what the center of it is generating all that information and then working with your, you know, in-house data management or working with the team that can provide you that relative to the site. And then Terry, we're working on a tool that people can do it with their values. So
Fenestration Canada, after hearing from a number of members that were running into this situation, we put together a task group, and Jomo Layton has been good enough to chair it for us for free. Thank you so much. So far, yeah. He'll get us. I know he will. So there's been a lot of meetings, a lot of discussion with government as well. And they are essentially, they went, oh my God, we really screwed up. Can you guys help us fix this? And they were really good about that they were looking for some guidance. So we're getting there. We've had some great progress. And hopefully sometime in 2024, we'll see the fruits of our labor, where there will be a easy tool to do that calculation for most product designs, and it will be acceptable.
And we can do it on the structural side too. The nice part about like AutoCAD now is you can actually calculate moments of deflection, all these things, like simulate them in the systems. So we can actually, just comes down to me, this is like, I need to make a decision to buy another delivery truck. It's like, I need to make a decision to develop data that demonstrates how our product can perform. So it's like, how much will your mullion deflect at PG 55 with a span of 10 feet? Do you know that answer? Do you have that information? 8 feet, 6 feet, you know, based on a 24 inches on center, 48 inches on center. If you look at the design manuals that engineers use for wood frame, steel, reinforced concrete, there's span tables in these books. Can you create that data of your own systems that allow generic designs to be implemented into the aspect? And so it's looking at existing tools that we have, that we've used very, very well in systems like Part 9, to basically apply to bigger systems. It gets harder with punched openings. It gets harder with multi-combination windows that are unique. And why I think it's good to look at, like, drive around and look at buildings from the 80s and older. And you'll be like, why is every window in those buildings the same? Right? And literally from probably the 90s on, we decided to customize everything and to be unique. And now the code is basically saying, okay, your custom product, unfortunately, now you have to have a design metric for everything. So we've kind of created this industry the way it is by our own actions and our own behaviors. And the number one pivotal change that we're all faced with is project specific. So start to think different. And this is like my message for today is think different is, how do I demonstrate project specific without knowing what the project specific requirements need? How do I do that? And until you ask yourself that question, you can't answer it. So, but there are ways to figure it out.
So the tool that we're close to will take NFRC model sizes and designs and run those calculations and get you numbers within, what was it, like 0.03% or 3% or something like that. Anyway, very close. Yeah, less than 2%. So very, very close. what Anton just mentioned was, what about things like reinforced mullions? And when you get into products that are non-metallic, we believe, at least I believe, that it's a bigger impact. You put a bunch of steel reinforced mullions in a PVC system, and the impact thermally of that is what? We don't know exactly. NFRC doesn't take that into account in most of its model sizes and designs. So that's our sort of next step in this process, is we're going to do some research and some modeling to get those variances, and hopefully build a tool that will address that down the road as well. We're getting there. We're making progress. So hopefully we'll get to it. Any other questions for Anton?
You talked earlier about specification documents, and obviously we've seen the cut and paste stuff going on and whatnot, and specific manufacturers in there. But when you say within there, it says, hey, use this pre-qualified system or whatever system. The gap that I always seem to run into when it comes to dealing with manufacturers or talking, especially when they're developing a new product or a new envelope product, whatever case may be, what are those pre-qualification guidelines that this manufacturer has met? They want to test to the same thing, but there's nothing in those specification documents that says this is the pre-qualification guidelines that you must meet. It's this or similar, but there's not a industry accepted, hey, if you're developing a new product, it's not project specific, but this is what you need to do to satisfy the requirements for architects to spec your product.
Yeah, I think you hit the nail on the head. Is, for lack of a better way to do it, lazy spec writing is to just say, hey, I like this product. It worked for me before, so I'll just spec it. And no developer, no general contractor wants sole sourced. So what do? They send it out to 10 different suppliers. Well, those suppliers now have to figure out what the specified product is that that manufacturer's not going to share. So how does that manufacturer even come close to knowing how to provide an approved alternate that's considered equal to what was specified? Because the specifier did not provide criteria. Now, they did, but a lot of it's copied and pasted. And like I used to bid on a lot of projects for residential, and the number one issue we always ran into was they would copy and paste a glazing spec that required 6 mil glass for residential homes. And you go, well, why? And they go, wasn't that the minimum glass thickness? I'm like, no, we can engineer it down to 3 mil. And that's just a classic example, but no one's giving you a list of, if your product can meet this criteria, you would be deemed acceptable for it. Now, good general contractors will let everybody bid on a project and then go, oh, you're the lowest 3 bidders. I'm going to bring you in with my design team to sit down around our boardroom, and we're going to hash out to make sure you meet the criteria. That's a good way to do it. I'll use Anthem Properties does that. Ventana does that, but not everybody does that. And so there needs to be, number one, a process in place. But number two, if there was one thing to consider an industry approach, would be, what type of document could you create? This is where I say, let's talk about change. What kind of document could we create that would allow an architect or an envelope consultant or anybody to look at it and go, oh, this product meets all the criteria? Now, I used to get a lot of requests from people saying, can you send me your 3-part spec? And I'm like, I'm a manufacturer, I'm not a spec writer. They expected the manufacturer to have a pre-written specification. Why? And I actually realized the manufacturers that figured this out 20 years ago wrote the spec and gave it to an architect to use. So that creates that basis of design concept. This is, number one, is recognize the behavior that's going on. And number two, I think you just identified an option that could come down to is a manufacturer to be savvy enough to figure out, what do I think an architect wants? What does an energy advisor want? What does a contractor want to see? And actually created their own sheet to spill out that information to give that someone would go within 30 seconds. Oh, you're approved. Actually, a quick little story. I used to work in the US and I had to apply for a work visa every year. The first time I went down, I thought, I'm going to research this and do it myself. I showed up at the border and I got like a little piece of paper and a letter, and the border guard's like, get out of here. Turned me around, my tail between my legs, and I'm like, I didn't get my work visa, even though I qualified. So I come back, ended up 3 tries I took and I finally got it. It was a real pain in the butt. I was like threatened to be like barred from the US like several times. So the next year I'm like, we got to hire an immigration lawyer. So we did. And they put together this beautiful package with tabs and cover pages and this. I show up to the border and I hand them the document, and the border guard, she looks through it all and she goes, wow, this is the most comprehensive application I've ever seen. Where's your passport? Stamp, stamp, stamp. Here you go. Took 2 minutes. So my question is are you trying to get your product approved option A or option B? What are you doing? And so it's looking at the systems we use to make it easy for an architect or someone to approve your product. So how do we do that? So
Any other questions before we call it? Anton, thanks so much. And I do want to restate what a great partner Layton Consulting is to Fenestration Canada. You guys have just been so much great work with us. We really appreciate you guys. So we're going to take 15, grab a coffee, visit an exhibitor you haven't talked to yet, and we'll have Casey coming up shortly from ICD to tell us all about spandrel glazing. 15 minutes. Okay, we're going to get going with our last session here this afternoon. So for this session, I would like to welcome Casey Anderson. Casey is the marketing manager at ICD High Performance Coatings and Chemistries, manufacturer of Opacity Coat 300 water-based silicone glass coating. She's must be later in the day. She has presented accredited education throughout North America to architects, facade consultants, general contractors, developers, glazing subcontractors, and glass fabricators. That's probably a lot of you guys, right? I think that's good. Casey stays informed of the latest architectural trends and developments by attending industry trade shows, including Glass Build America, Facades Plus, ZAC World of Facades, Facade Tectonics World Congress, and NGA conferences. Participates in several NGA work groups to further industry technical resources. She was a facilitator and speaker at the New York Build Week 2022 and has been quoted in Glass and U.S. Glass magazines regarding facade visual harmonization, material compatibility, spandrel, back-painted glass. Was amidst industry icons in December 2022 U.S. Glass magazine cover titled Women in Industry. Casey enjoys collaborating on projects with people who strive to further green initiatives. Casey, welcome. We're looking forward to it. Audio? Yep.
Thank you so much. I am so thrilled to be here today, and I'm so thrilled that everybody stayed throughout to the end of the day. There's goodness coming at the end from our wonderful, one of our sponsors, Sherwin-Williams, is providing a mixer, so it's worth it. Stick with us. I'd also like to do a shout out to Anton. He doesn't know it, but a lot of the concepts that he discussed, we are going to be rediscussing and reaffirming in this presentation. I also just want to do a huge shout out to the Fenestration Canada team. Rich, Lane, Terry, everyone here has done such an amazing job for the first inaugural event. Thank you so much in getting everyone together. As Terry mentioned, my name is Casey Anderson. I'm the marketing manager for ICD. And before we get started, I just want to mention a little bit of history for ICD. So ICD was established in 1986, and our owners were actually glass fabricators before we were coating manufacturers. They had employees that actually got sick, specifically handling the chemistries that were around in the 70s. And they were so motivated from people physically getting ill that they were motivated to get into coatings. And so that's where we landed in our water-based and sustainable chemistries in today. Oh, wrong direction. There we go. Okay. This is an AIBC accredited presentation. So we're just going to, there we go. So today we're going to go through our learning objectives, and these are the 4 as listed. We have our understand the functional aesthetic advantages of specifying silicone coatings in CSI Master Format Divisions 8 and 9. We're going to describe how to effectively convey project-specific application requirements and silicone coating specifications. And we're going to define applicable standards, testing, and codes related to opacifying glass coatings. We're going to learn how to employ proprietary, prescriptive, and performance-based specification methods to defend silicone coating product selection, but really products in general, utilizing information, as Anton pointed out, ahead of all of that work to make sure that what you want and the efforts that you put in at the front end are actually going to happen and get built for you. So this presentation was actually built with a lot of things in mind. This is available as a PDF. If you're interested, feel free to stop by the tabletop afterwards. We're happy to send this PDF to you. But we do mention part 1, 2, and 3 based on the specification topic we're talking about. We have suggested specification language text. I know Anton mentioned that some manufacturers have a 3-part spec available, but we're actually suggesting bits of language that you can use. And then it's actually cut off at the bottom, but we do mention the sections that we're working in as well. So we want this to be a very easily accessible, digestible presentation for you. So for openings, Division 8, we definitely want to just do a quick overview. I'm sure everybody in this room knows exactly what Division 8 is, but it's elements that fill openings, including door, windows, skylights, glazing materials, and hardware. And then Division 9 finishes. How many is working? There's probably a few people working in finishes in here, but I'm actually going to introduce the idea of Division 9 finishes for interior building blocks, wall ceilings, floors, and paint, but also as interior back painted glass surfacing. We are surfacing the wall with back painted glass. Okay. Next, we're also going to define spandrel and back painted glass. So you're going to use desired opacity when you're utilizing the spandrel glass or wall cladding, and you're going to install it in non-vision areas. We have all encountered that project where we walk onto the site and someone goes, I've installed back painted glass in a vision area and now I'm seeing light transmission coming through. It happens. We have actually a picture later in the presentation that shows it. It should, spandrel glass and back painted glass should not be in vision areas. There are products that specifically can work for that, but it's not coatings themselves, liquid coatings. And the interior surface is actually not suitable as a finished wall. And it has to have the full installation finished, it needs cavity backing to block the light. That's actually a finished, approved application of spandrel glass. So we're just going to show a couple examples here. So the function of spandrel glass is to conceal structural and mechanical element features like HVAC, columns, sprinkler systems, floor slabs. So here we're looking at the interior of a building space. The spandrel is actually where the foil is at the knee wall area, and just above that, that's going to be hiding a hung ceiling and a sprinkler system. You actually can't physically see the spandrel because you have the airspace, the air gap, and the insulation, the foil-backed insulation here. To actually finish this out, you're going to have your hung ceiling, and then you're having your finished knee wall. From an aesthetic standpoint, when you're looking at the outside of the building, you have the banding opportunity, you have harmonization, you have material mimicking. So you're not only producing a functional aspect of that, but you have an aesthetic choice as well. And I say you, but it's usually the architects or the designer that's making that decision. And then most of the people in this room are executing that. I don't think we had any hands raised when we asked for architects earlier. Do we have any? Excellent. Wonderful. It's your responsibility. For back painted glass, Division 9, Section 7, so we have wall cladding, marker boards, furnishing, shower enclosures. So not just the glass that's, encasing the shower, but think about all 4 walls potentially being glass and having back paints on there as well. Backsplashes and also countertops. So before we get too much further, I do want to highlight silicone coating chemistry in particular. It's a 100% water-based formulation, which contributes to both aesthetics, longevity, and sustainability aspects. It's naturally bonded to the glass. There are chemistry anomalies and things that create glass and silicone coatings, they really like to be together. They're naturally chemically bonded. And the coating itself is cured through the evaporation of water at either ambient or low temperatures, which is also very environmentally friendly. The result is it becomes a durable, tack-free, elastomeric, or rubber-like film with outstanding adhesion. And as we go through the CSI facility life cycle, really we're going to highlight the different sections and when design choices can get made. So conception, coated glass is actually not likely considered at this point. It's too early. We're talking about form, we're talking about space, we're talking about very abstract ideas. Materials aren't necessarily considered at this level. And then we go into design, where coated glass decisions are actually made and material decisions are actually considered, the types of finish and functionality. Construction documents, coated glass decisions are finalized. We're going to go into the specification side of things at one of the other learning objectives. And then we have procurement, coated glass decisions are implemented. Construction, coated glass is installed, and facility management. So there's actually no maintenance required for the coated glass once it's installed. And then coming back around to conception could also be a retrofit opportunity, an expansion, an addition, something like that. So we're actually going to highlight a little bit deeper where there's 4 check marks are. And so digging into design, the design team, usually the project architect, designer, consultant, owner, developer. In conceptual design, definitely the glazing is theorized. In schematic design, glazing, you have your elevations, and in design development, you have your material selection or your material evaluations as well. So that's your typical design to build. And then if we go to design build, which Anton was highlighting, is getting team members in earlier on the conversation. So involving contractors, glazing subcontractors early in the design phase. This also allows for advanced decision-making and contributes to accurate early cost estimations. So you're not doing giant change orders down the line. So this list grows, obviously, because you're inviting more people to the table. So next in construction documents, we have green certifications that can be included, manufacturer's color range, compatibility considerations, correct methods of installation, and application capabilities. So this is usually the specifier or a consultant if the specifier isn't specifically at the firm, an architect or a designer as well. And really emphasizing that the product is selected for longevity, functionality, and the aesthetic aspect. It's not just about the design, that it's actually meeting the requirements of what type of building you're looking to build. Are you building a 10-year building? Are you building a 50-year building? Are you building a 100-year building? What are those choices getting aligned around? In procurement and submittals, you have you're confirming the design intent, you're requesting samples, and you're determining performance. You're reaching out to the product manufacturer to make sure that they are backing up those claims that the salesperson just happened to say was, this is a great product. You should choose it because of this. To Anton's point as well, you should absolutely reach out to the manufacturer and make sure that they have the documentation, third-party testing, et cetera, to back up those claims. And then we also have from a pricing side of things. So you definitely can contact the coating manufacturer, the material manufacturer. You can identify which fabricators have those products. And I really like to encourage resiliency in sourcing. There is a benefit to having a network of opportunities to purchase products. There is relationships that are built over time, but if those relationships aren't serving you any longer, if you're not finding the information that you need, dig deeper. Take 5 more minutes, make a new phone call, make a new friend. Highly encourage that. In construction, the coated glass is installed. So we definitely want to make sure that all of our team members are aligned on job site storage, material handling, and coated surface preparation and troubleshooting. You want to definitely confirm also component compatibility. That's huge. We don't want things to go together that are going to pop up, miraculously or mysteriously 6 months down the road, 3 years down the road, and fail through staining or something else like that. So key points of what we just went over. We have spandrel glass and protective glass coatings are specified in Division 8 openings, Section 8 glazing. Back painted glass surfacing and protective glass coatings are specified in Division 9 finishes, Section 7 wall finishes. And spandrel glass material decisions can be evaluated during design development and is highly encouraged to be done so. So next we're going to describe how to effectively convey project-specific application requirements in silicone coating specifications. So getting into our three-part specs. Part one, we definitely have the general, there's definitions, administrative, how often are we meeting together, what are the requirements on the quality, the submittals, what are the warranties, all of these things need to be captured. In part two, we're describing the products that we're using. We're getting in depth based on different terminology. We're going to talk about prescriptive, performance, or proprietary specifications a little bit later. That's where a lot of this language comes in that we're going to go through. You may include the manufacturer from a proprietary standpoint, or hopefully you're not saying or equal to. We're actually going to work through how to not do that and put in the information that you need. And then in part three, we are examining the conditions, installing manufacturer requirements, disposal, preparing surfaces, and protecting. A lot of this has to do, too, from a manufacturer's requirements of how qualified or experienced is the contractor that you're working with. Are they familiar with the product? Or is there education available that they can take that shows that they are certified in application or installation of the product? How comfortable are you with your installer is basically how I like to look at that. For technical requirements, so part two, we're going to look a little bit deeper into, so we're going to look at an IGU for an example. For silicone coatings is going to be our example here, but something to consider in coatings in general. So surface one for silicone coatings is not applicable in an IGU application. Surface two in an IGU can be utilized. You're going to get a contrast and a color pop. You're also going to get lower reflectance because really you're just dealing with surface one and surface two of the glass reflectance, but that color is going to be way more upfront, have more of a color pop opportunity to it. Surface 3 is possible, but it's actually not recommended because you're going to be looking at the applied side of the coating. You're going to see possible application marks. I'm seeing a lot of head nods here. They might have seen what that looks like. When that's specified, we do see that quite often come in, and we usually make that recommendation that surface 3 is not, even though it can be done that way, it's really not meant to be. And in surface 4, that's actually best for a look of depth, facade visual harmonization, and higher reflectance. You now have 4 surfaces and even potentially a low-E coating inside of that IGU to help with harmonization as well. Speaking of low-E's, we're going to talk a little bit about hard coats and soft coats. We got Guardian and Vitra in the house. So having and including a low-E coating inside of the IGU for your spandrel options from an aesthetic standpoint, this is actually going to harmonize best if you're continuing from your vision unit down into your spandrel unit. You're continuing with the same low-E configuration. So hard coat low-E's are out there. There's pyrolytic low-E's. Those can be on surface 2, 3, or 4 because silicone coatings can actually be compatible on a pyrolytic hard coat low-E. For soft coat low-E's, those are generally going to be on either surface 2 or surface 3 because of the soft nature of them. If that is the case, the silicone coating actually does have to move to surface number 4. There's incompatibility within the airspace. So if ever you see, surface 2 low-E, surface 3 spandrel coating, that's not an appropriate configuration specifically for silicone coatings. So for technical requirements, this is some of the pictures I was mentioning earlier. You may or may not have seen this type of application where somebody is specified spandrel coatings but has not put in the cavity backing for the appropriate view. And then they install it and they say, well, what do we do now? And the only answer to that is you either get to live with it or you pay to have either cavity backing installed or you pull everything out and you redo it altogether. So really, really, really important to make sure that where you're detailing coatings, liquid coatings being applied to transparent glass, they're spray applied or they're roll coated applied. There's not a uniformity as there would be like in a film or a laminate. So there are products out there that can produce that if this is the detail that needs to happen. Okay. The suggested language to be used in a specification is follow the manufacturer's installation instructions, because there is documents of the appropriate usage. So really it's just those finite amount of words puts the onus on the subcontractors to look up the information of how it's recommended, and they would be able to see that opportunity and possibly stop that from happening. Technical requirements and compatibility. This is, and I also mentioned, you know, staining and other stuff. 56% of failures that happen like this are 100% preventable. There are compatibility, single testing component compatibility opportunities, and you can always contact a manufacturer to learn more information on what things should and shouldn't play together. Testing does take a little bit of time. It's a 30-day, goes through QUV, humidity. There's lots of different angles for compatibility testing. So lend it some time to do that. It's roughly about 30 days. So try not to go, oh my gosh, you know, I need this tomorrow. It can take a little bit of time because we want to make sure that it's proper and correct. The language suggested to get added into a specification in part 2 is all accessory materials required to comply with coating manufacturers or product manufacturers' current compatible materials list. That puts the onus out to find that list, make sure that it's covered, and we're good to go. Technical requirements on fallout resistance. So this is really unique for silicone glass coatings in particular. If you apply a silicone coating at 13 mils wet film thickness, it provides temporary glass retention. Fritted spandrels in particular, or ceramic enamel spandrels, need an additional applied film to achieve this. So this is a naturally inherent capability of the coating itself for silicone coatings. It isn't a substitute for security or safety glazing. I do have to mention that. But this is the language that is encouraged. Passes ASTM C1048 for an assembly of glass and adhered reinforcing material. Coating thickness, 13 mil wet film thickness applied to 6 millimeter tempered glass. So if that tempered glass were to break or shatter for any reason, it would be temporarily held into place until it could get replaced. Okay. Applied color considerations. So virtually any color is possible with silicone coatings. There's a few ways that this can be described in part 1, actually, and part 2. But you can, from a proprietary standpoint, you can say color name and color number. That's going to be very specific to the manufacturer that you're getting that sample from. You can't say then and equivalence, because then people are trying to get samples from each other and trying to do color matches, and it's kind of messy between different manufacturers. Another option you can do is harmonize with vision glass type. So if you're not going to go through the process of figuring out a specific color that you want, name, number, proprietary manufacturer, you can describe the aesthetic design intent of the glass, and then the contracting team can then reach out to the coating manufacturer and say, how do I achieve this? Okay. And then option number 3, you can match another paint color. So you can use a color chip fan deck type situation. And you can say, this is an example, RAL 7032. I want my spandrel to look like this, or I want my back painted glass to look like this. And then that's also the mode of color matching that people can use to head down that road. So for applied color considerations, the glass 100% matters. I have some examples on the table over there that we can look at afterwards if you haven't seen them already. But between color compounding, there's not only thickness differences, 6 millimeter, 12 millimeter, you also have low iron glass. You have new mid iron glasses that are coming out. You have clear glass. You have laminated configurations as well. Every single item actually compounds the color of how you're viewing all of those materials together, and the reflectance and the lowies added in. And, all of these things matter. And so when a specification is built with a specific unit configuration in mind, and you've done the work, the design work to say, this is exactly what I'm interested in doing, it's really hard to find equivalence from that. Maybe from a performance standpoint, but from an aesthetic standpoint, if you're shifting manufacturers, it's really hard to line that up. And I would advocate that from a coatings aspect, especially for your spandrel, a lot of the times colors are made specifically based on the configuration. We're handing over a sample on a glass substrate based on your specific project. So let's say it's a monolithic low iron glass that you've selected for your spandrel. And down the way, we're VEing and we say, gosh, we really need that on a clear. That's going to transform the look of how your spandrel is performing and looking, right? So you need to consider one small change might actually create a ripple effect. You might need to get a new sample and some new information around that change as well. So color compounding absolutely matters for applied color considerations. Oh, I kind of already mentioned this. So, but the language specifically, you can include, the glass manufacturer, the glass clarity, the thickness, and a low-E product if available or applicable. You would, they're definitely available. People should be using low-E's, but if applicable to the project. From a proprietary aspect, if you're not including the manufacturer, definitely performance calculations and how those need to be met, and then reviewing the aesthetics before it gets locked into a contract. So combining technologies, there's a few trends and items. I know Geoff mentioned that earlier a little bit today. So there's a few different ways that silicone coatings can actually pair really beautifully together. There's digital printing with ceramic enamels and frits now. Very complicated patterns can be created. Silicone coatings can actually flood coat. So you could use let's say a frit screen print or digital print pattern on like surface 3, and then of an IGU, and then you could use the flood coat spandrel coating on surface 4 in a whole nother color. So you can create really cool design opportunities by using multiple technologies. Another one is bird safe. We're seeing more bird safe, bird friendly glass out there. Silicone coatings work really well with acid etch and even UV products that are out there. The other aspect of that is because of the ambient cure or the low bake oven cure. There's some compatibility that needs to be confirmed on which finished products can actually achieve that. And next is green coating characteristics. You definitely want to consider language, health product declarations. We've talked a lot about EPDs. Been hearing that a lot today. I was going to say HPDs are also available and out there, and they're part of the LEED point system. So health product declarations. They're currently on their version 2.3, and great information that can be included in a specification is like that the product includes an HPD at version 2.3 at a threshold level of 100 parts per million. Or Living Future Institute actually has a fantastic pedal structure on how they organize their project certifications. So they actually have, as a part of one of their pedals, their material pedal, is that a product wouldn't contain red list materials. Has anybody heard of the red list? Handful of people. Okay. So yeah, it's very important that if you are interested in saving the planet just a tiny bit, little bit, the red list is something that is collected by a group of people, volunteers, just such as yourselves, but it's a bioaccumulative, it's basically the nasty stuff that's in the world and things that we want to try and stop using. So the benefit of putting language in specifications is it sends a message to the manufacturers saying we're not going to tolerate these types of materials in our products, and we're going to prioritize those things. Okay. So, the other thing was green coating characteristics too with water-based. So the other thing for me, so solvent-based coatings, they definitely contribute to ozone pollution during the curing process. That's what's getting released from the coating for it to coalesce or cure. And so, pollution, also, production employee health issues, but, PPE, sure, but it's still getting released into the environment. It is interesting to also be very conscientious about greenwashing. I don't know if you've heard of this term, but the idea is if like water miscible, you see the word water, you go, oh, that's good. This is great. I'm using a water something coating, right? Water miscible actually means water reducible. It can actually be fully on solvents up to that point. So that's definitely something to consider as well. And by including in your specification water-based, that actually means that the base of the product is a majority percentage of water. So that's really important. Very specific language that can be included. Okay, so we got some key points here. So we have technical requirements, including surface applications and compatibilities, aesthetic considerations, including applied color and chosen substrate, and then green characteristics, including water-based chemistry, health product declarations, and red list free compliance as well. So we're going to define next applicable standards, testing, and codes related to opacifying glass coatings. So not green coating characteristics. Oh, it got out of order. That's fun. So ASTM C1048 is a fantastic ASTM standard that is an intent of inspection. The idea is, and it's funny, I have little backers behind our samples over there, but one of the first inclinations when anybody gets a coated glass sample, what do they do with it? They hold it up to the light. But didn't we just discuss earlier that the actual application of spandrel has to have cavity backing? And not, like, you're going to have that air gap, you're going to have the insulation. Why would you need to know that it can block the light or how translucent it is if it's meant to function in the way that it's installed, right? So by including the language, pass ASTM C1048 standard specification for heat strengthened and fully tempered glass, that actually includes this reviewal process in section 831 for appearance and section 1010 for coating criteria. You're going to stand 10 feet away from the sample and you're going to put it up against an opaque substrate and you're going to look at it like it was installed. So you're not going to do it inside of your office. You're actually going to go outside, breathe some fresh air, and you're going to look at different reflections, especially if there's a low E coating involved. You want to see how that's interacting on those different surfaces. So that's a really important one from a reviewal process. Adhesion testing. You definitely want to make sure that the coating stays on the glass or the material performs as it's supposed to, right? It's kind of important. We don't want to go back and replace stuff if it falls apart. We want it to last a really long time. So you're going to, you want to make sure that the adhesive characteristics of the cured coating perform well. You're going to look at ASTM C794. It's a standard test method for adhesion in peel of elastomeric joint sealants. And the text that goes along with that is pass peel adhesion test from ASTM C794. Super simple, right? ASTM D4541, standard test methods for pull-off strength of coatings using portable adhesion testers. So I put some placeholder language in here, achieve 400 PSI on ASTM D4541, but you would put in project specific requirements in that block. And then ASTM D3359, standard test methods for rating adhesion by tape tests. So once again, achieve a 5B on ASTM D3359, but you do it based on your project requirements as needed. ASTM G154 is a big one too. This is for environmental durability. So you have accelerated UV exposure. There is a heck of a lot of interaction with the elements from a spandrel aspect. You have temperature swings, let alone what we were talking about earlier of peak loads. I mean, just in 24 hours, the amount of temperature that's exposed on spandrel is intense. So you definitely want to make sure that it can withstand the UV exposure. There's QUV chambers that are used with UVA bulbs that best mimics filtered light through windows and test the color fastness. You don't want that that beautiful spandrel that you just installed a year later, all of a sudden is faded, doesn't have the performance capabilities. So the language that would be suggested would be pass ASTM G154 standard practice for operating fluorescent ultraviolet UV lamp apparatus for exposure of non-metallic materials. NGA specification 891-69 is also an amazing thing to include. I think I saw Andrew's in the house, NGA, yeah. So intent for environmental durability, that's what I was talking about with cyclical testing. You want to make sure that the product is performing. Yeah, you don't want to necessarily not include any of this and fully accept, spray paint applied to the glass. That's not going to last a very long time. It wasn't meant for that application. There's very specific standards. So the language, and after doing all this testing of high-low temperatures, high-low humidity, 100+ cycles of cyclical testing, it has to pass with no bubbles, peeling, crazing, cracking, tunneling, shrinking, staining, discoloration, or delamination. It's pretty rigorous, right? Because we're making buildings to last longer. We don't want to turn products around quickly. So we're going to pass, the language we're going to include is pass NGA Engineering Standards Manual, specification 89-169, environmental durability for heat-treated spandrel glass with applied opacifiers. The other NGA specification is a glass technical paper, FB 70-20, and this is the intent of eliminating undesirable performance. This is also can be included in part 2 of the specification. It addresses elements of adhesion, proper installation methods, and dynamic forces. It's literally as simple as saying abide by this GTP best practices for installed back painted or painted decorative glass. I'm going to maybe introduce a radical idea. You can use European standards in North American specifications. And the reason that I'm suggesting that is because we actually don't have a standard written around glass weakening right now, but Europe actually does. So the standard is European 12150-1. It is the intent to reduce the risk of thermal stress breakage, which you may or may not have encountered in the field, possibly in a replacement or in a analysis. So the European standard is based on thermal toughened soda lime silicate safety glass, but because we don't have that standard here in North America, we lean on the 4-point bending test, ASTM 1161-13, and ball drop by NGA 761210A. But really the basic language that can be included in part 2 is weakening of glass tested to not lower the tensile strength of heat-treated glass. It's that simple. And then your contractor is then getting those documents to prove that that's what the product can do. Okay, key points. We talked about applicable testing standards for spandrel and back painted glass. That includes coating glass inspection, environmental durability, adhesion, and glass weakening. Coating technology is chosen to satisfy the desired application. Make sure that you are not copying and pasting unless it's project specific and project applicable. You don't need to go to the nth degree for every single project. So once you put all this stuff in, you pick and choose based on where the needs are, because otherwise you might also be paying unnecessarily, right? Based on the project needs. So last and not least, We're going to learn how to employ proprietary, prescriptive, and performance-based specification methods to defend silicone coating product selection, but really just material selection in general, because we've talked about doing the work up front and including this information. So we have exterior spandrel glazing in Division 8, Section 8, as we discussed, glass surfacing in Division 9, Section 7. So you're going to include the glass substrate. Be descriptive, be maybe specific with your specification. So you're going to include, is it monolithic? Is it insulated? Is it double? Is it triple? Is it laminated? Is it clear? Is it low iron? Is it tinted? Is it specialty? If there's a low-E included, what are the thermal performances? What are you expecting for it to do to you for the products? And what is the thickness of the glass? And what is the strength requirements of the glass? We ask a lot of our glass and glazing products to perform, to keep us safe, to keep us warm, to keep us cold, you know. There's a lot of things that we expect of it, but unless we're detailing those things up front, we're not necessarily going to get the performance that we need on the back end. For the coating technology selection, there's 3 different methods we'll go through: proprietary, prescriptive, or performance. You can include the color name and the color number if you've done the design work and you've locked in on a look that you absolutely want and have to have. If you include that and you include and other materials, there will be color matches attempted, okay? Opacifying surface orientation also matters, as we discussed. So surface 2, monolithic, or surface 2 of an IGU, surface 4 of a double IGU, and or surface 6 of a triple. We started seeing triple spandrels come through our office for samples recently. As the code is changing, people are adjusting accordingly. So for proprietary specifications, we have some best practices. Proprietary, say the name. Be as wide open with all the information that you've gathered. Product name, coating manufacturer, product manufacturer, and connect with your manufacturers. Make sure that they have a third-party specification review. Or if they're handing over a 3-part spec, please make sure that the salesperson sitting 2 desks over didn't, write it together in 15 minutes, right? Make sure that it passed through an actual third-party specification consultant before that gets copied and pasted in any way. For the manufacturing resources, you definitely want to make sure that any other documentation that's provided has also gone through a thorough review as well. For prescriptive specifications, we talked about a lot of information, but also we talked about the chemistry, right? So you can include information without being specific and including the name. So for an example, you could say silicone coated spandrel glass. That's not a proprietary brand name or a product, but it does zero in on the prescriptive chemistry that you would like to be used. From the language side of things, we also talked about water-based, so you can guide that activity to get that sustainability aspect in there if that's important. And from the methods, you can also say, I need to see that a glazer has taken a certification course and knows how to handle this product on site and for installation. And then also you can require that there are certified glass fabricators in the application of the coating as well. So there's definitely ways to narrow down the scope without having to sacrifice too much coming out of proprietary into prescriptive. From a performance best practices, we talked about a lot of ASTMs and standards. Definitely want to obtain the applicable documentation, coatings that don't weaken glass, the inspection methods of the glass, the coated glass, the coating thickness for performance needs. We talked about fallout resistance, adhesion for durability and testing, third-party VOC reports, health product declarations at 100 parts per million, and living building challenge red list components. Those are all things that can go into a performance specification. Once again, it's not proprietary information. It's how you want things to be guided to make the product selection. The issue and the gap that normally happens is when some of this information goes in it's very difficult for the contractor to find the product that actually meets all of that. So if you're on the supplier side of things, I implore you to make this information easily obtainable on your website or in downloaded information. That's going to be crucial to make sure that when you see prescriptive and performance specifications, that your product can get selected based on that readily available information. And I'd like to really point out that not all substitutes are created equal. Anton talked about, equal alternatives. Some products just do not have equals in the market based on performance needs. And silicone water-based coatings are sustainable, high-performing coating technologies. You definitely want to eliminate the risk by defining project-specific specification requirements. And you can update your basis of design without proprietary information, as we just stated and walked through all of those standards. So kind of on that theme of not all substitutes are created equal, I would encourage you to have an arsenal of questions built up, because if you're opening up Pandora's box of equivalent products, make sure that you understand the standards and the methods that you included and build questions around them. For example, has the product been tested to prove it doesn't weaken glass? Right? Because you want to vet and make sure that the equivalent product is actually meeting those specifications. Accepting a change submittal, saying that it meets the requirements, is just like saying yes to the salesperson that says it's a really good product. So key points: spandrel glass and glass wall surfacing can be specified using proprietary prescriptive and performance methods. And architects and glazing subcontractors have a variety of resources to access and meet specification requirements, including educational courses, installation and application guides, certified fabricators, and sustainability documentation and third-party verified literature. And that's what I got.
Any questions for Casey? That was a lot of info. Okay, hang on.
Sorry,
Geoff?
it was a lot of info.
So with the surface coating on 2 for an IG unit, it's a 4-sided SSG. How do you work out the picture framing disappear with the manufacturer of the glass, or have you done that?
That's a really great question. I would say that the sealants that are available for 4-sided structural glazing have a little bit, there is color matching that is available, but I would say it's a lot easier to start with the color of the sealant and then reach out to a coating manufacturer for color matching. That's going to be the best way to harmonize and to reduce that frame, because you're right, it is required to have edge deletion for that 4SSG application to get the bite on the glass.
You had mentioned something about compatibility issues with silicone-based paint with different kinds of substrates, and I saw on the screen there was a mention of acid etch. Is there an issue with that in general?
There isn't an issue specifically with acid etch because acid etch glass is actually produced ahead of the silicone coating being applied on the glass. I actually have some examples at the table of where we have acid etch on surface 1 and silicone coating on surface 2. Those are beautiful combinations. I would say to keep the acid etch look, you don't want to, let's say, put acid etch on surface 2 and then put the silicone coating on top of it. It might completely negate that design interest. Great question.
Anyone else?
I know we want to get to the mixer. So.
Okay, Casey, thank you so much.
Thank
Appreciate
you.
it. Okay, so that was a day, wasn't it? That wraps up our education for today. I have some thank yous and some comments. Great crowd. We're so pleased that there was so many people that decided to attend today, and we hope that we didn't make too many of you stand for too long. Next year we'll have more seats because we'll have better expectations. There's a few things that are coming up for Fenestration Canada and the industry in the next little bit. So I just want to mention those. Our residential Pacific chapter is meeting out at West Tech Windows on Thursday of this week. We've got a few education sessions. They're going to be doing a demo on their test wall of a structural test, as well as opening their showroom for everybody to have a peek. So if you're interested in what they're doing and can make it out that way, I know Chilliwack is almost Alberta, but if you have time and you want to join us, by all means, just touch base with Lane or Isabel for the reg and come on out and see us. Top Glass coming up at the end of April in Toronto. So hopefully people can make it to that. That's always a great event. And then the Fenestration Canada Spring Conference coming up at the end of May, 29th to 31st in Kananaskis, Alberta. Not too terribly far from here. So we'd love to see somebody there. Same thing, you can talk to Lane and or Isabel for info about that. I want to thank our exhibitors. Really want to thank you guys for coming out. It looked like there was lots of activity going on. Hopefully it was beneficial for you guys. We appreciate your coming and spending the day with us. And of course, our sponsors. Again, we cannot do this stuff without our sponsors. Are they listed? Yeah, Sherwin-Williams, JSA Machinery, Pref ERP, Tremco, CAD-PLAN, ScreenCo, INT Machinery, Servitec, and Glass Canada. We appreciate their support. And again, we really thank you guys for being here. My name's Terry Adamson. You can reach me at terry@fenestrationcanada.ca. If there's anything I can do to help you or find something for you or give you some guidance on something that I might know something about, by all means, reach out to us. We'd love to have you as a member if you think that we're doing something good. So again, Isabel is our member support person. Touch base with her. We'd love to have you as a member as we continue to grow our association and our activity, especially on the commercial side, which we're obviously doing more and more of that. So in a few minutes, we're going to have some beer and wine courtesy of the folks from Sherwin-Williams. Thank you so much for coming today. We really appreciate it. And I hope it was worthwhile for you. Thank you.